Ladies and gentlemen, welcome at this very impressive seminar this afternoon on how generative and predictive AI are shaping the future of industry. My name is Wim van Kouwenberg. I'm a director at BEMAS. I will explain BEMAS to you right away, but first of all, I have to say that both SymphonyAI and we as BEMAS are impressed by the number of participants showing up for this topic. Apparently, that's something that is a lot of people working in the industry are looking at, and so we are very happy to be able to inspire you this afternoon. First of all, I need to thank also the corporate sponsors of BEMAS. You see the logos here mentioned on the screen. And of course also SymphonyAI for the very close collaboration for this afternoon. For those who don't know BEMAS, BEMAS is a not-for-profit organization. We are here by members, for our members. Our mission is to help you to improve in the field of maintenance. We do that by organizing courses, but also inspiring people, inspiring you, and I'm sure of that we will do so today also. If you want to have the handouts of this session, you can download those at the BEMAS website. So you go there in the upper right corner, you do login, and there you will find the handouts of all the activities and courses that you're taking with BEMAS. So don't hesitate to download them. There's a QR code also on the handouts on the back side of the program. Then also a small announcement for those who are speaking Dutch. We have also launched a podcast with BEMAS called The Tree Maintenance. We're doing a visit at factory sites, and we have already done a first one at the NMBS, which is the National Railway, and then we have also the new one that has been launched just Monday at the site of Renewy, which is a recycling plant. So it's a hard work. It's 1 hour podcast, but very inspirational. So if you want to go to your favorite podcast program, The Tree Maintenance. Then another thing, we have with BEMAS, we don't only do webinars and train and give trainings. We also participate in projects, and this is an interesting project which is called Smartens. It goes in the field of data spaces, which is trying to make an open collaboration platform in order to be able to share data. It's called a kind of a next generation internet, and this is the project is focused on developing such a thing for the field of maintenance. And with BEMAS, we are a small partner, and we will try to keep on informing you on how this evolves. Okay. That's the agenda for today, and I would say, without any further ado, I would like to invite Mr. Pratik Kaptal, who is in fact the president and the CEO of the Industry Solutions Division at SymphonyAI. Pratik.
Thank you. Thank you, everyone. Thank you for coming over, and again, welcome. My name is Pratik Kaptal. I'm President and CEO for SymphonyAI Industrial. SymphonyAI is a company. We're based out of the Silicon Valley in Palo Alto, California. And the company was founded and started in 2017. Thank you. The industrial business unit of SymphonyAI, sorry, I need to go back. We are participating in several different industries, whether it's oil and gas, chemical, food and beverage, pharmaceuticals. We're part of several different industries. We have solutions which span across all these different verticals in manufacturing and industrial. At the same time, the solution is, and we'll talk about that, we'll show you a demo today. The solution spans across multiple different segments within the industrial and smart manufacturing segment in itself. We have offices all across the world with, I would say, engineers, data scientists who are obviously here in Belgium, but we have people in US, in India, in Europe, and even in Middle East as well. So we're based all across the world, wherever the manufacturing lines are for different companies. We're today more than 5,000 people worldwide as a company, so we're growing as an organization, and very, very excited we're here to be part of this session today and the seminar. Now, when I say SymphonyAI Industrial, we focus on 3 different segments, and as you will hear about our products today, as you'll hear about the different solutions on the predictive AI, the generative AI, which is obviously very exciting and enticing on where the world is going. We focus and we divide our products into 3 categories. So assets, the machines, is one critical part of your, I would say, industry and smart manufacturing. Then there is the systems, the processes, the recipes, the production that you're doing as a part of your industry. And then finally, the people, who are part of the I would say, the industry itself. What we try to do is we bring all the assets, processes, and systems together, and people together, and that's where we add the data layer, we add the generative AI and the predictive AI layer on top of that, so we could get the maximum efficiency when it comes to the people. You can get the maximum productivity when it comes to the processes. You can get the maximum efficiency and ROI when it comes to your processes as a part of that. We handle today, just to give you a very quick idea, in terms of the scale, we handle today more than 250 gigabytes of data transfer per hour on the SymphonyAI platform. So it's a platform which is in production in thousands of plants worldwide, 6 million plus data events which are tracked per day as a part of this particular platform. Now, what we have done is we've also, at the heart of this smart manufacturing platform, our SymphonyAI platform, is what we call as Iris Foundry. Now, Foundry is a data platform. It's an industrial data platform which allows you to do data orchestration, data contextualization. It allows you to do unified namespace. It allows you to do data transformation, add your AI ML pipelines, and then get data insights on top of that as well. This is our, I would say, first foray into the area where you will see that this allows you as a studio, as a platform, to not only go in and create your predictive AI models, generative AI models on top of it, but then also deploy that live into the production and do simulation on top of your sample data or on top of your actual production data, run those simulations in real-time environment and be able to get the results, calibrate on those results, and keep on fine-tuning them and see that as a part of your insights, or whether it's a SymphonyAI insight tool or any other product that you like for your dashboarding and insights, you could actually push the data back into that as well. And I think that's the flexibility over here that the Iris Foundry offers, and we'll show you some of that today. The Iris Foundry does also include, as a part of that, a knowledge graph and an ontology layer as well. So as we are bringing in data from the different sensors, the different data sources across the plant or multiple plants, we create this knowledge graph, which is able to show you at a single glimpse what is going on at a particular asset level, the different tags, or across the plant or multiple plants, all at a single point of view. And you can keep on going deeper and deeper into the from a plant to an asset level, to even when was the last time the maintenance done, or what was the FMEA analysis on that particular asset. So you can keep on going deeper from that knowledge graph. And all that is available as a part of the Iris platform. And then finally, the top layer on top of the Iris is the generative AI copilots. What we did about 3 months or so ago is we have a partnership with Microsoft, and we introduced, in partnership with Microsoft, the world's first large language model. And this is a model we trained on 2.5 trillion data points, which SymphonyAI has collected. This is the data that we had collected over time. We trained this large language model on that large amount of data. And that large language model is now available publicly, which uses the LLM along with the Iris Foundry and gives you this copilot, which can now answer pretty much any question in a chatbot format. So I can show you a quick demo of that, a pre-recorded demo of this over here. So this is a SymphonyAI Copilot demo. It uses a natural language kind of a format to answer any question. It can sit on top of your Insight application, any dashboard, and you can log in, you can start asking questions. It can dig deeper into your plant data or your asset data. And as you're asking the questions, since it's connected behind through the Iris system, the Iris Foundry, it knows exactly about the plant, about the multiple plants, the assets, and the derived assets as well. So it can now give you full contextual information about the issue that you're asking about. Like in this case, the person asked about a certain asset. It could create time series chart data. It can also give you the visualization. You can go deeper into that particular asset, but you can also do prediction on that particular asset as well. You could do time comparison, time series based comparison between the two assets. You can do prediction based efficiency comparison as well on multiple assets as well. Again, you can keep on spending days on what the Copilot could do. It's very similar to if you guys have used ChatGPT in a normal world. Think of this as a ChatGPT on steroids for industrial data. That's what this product is. And the Copilot is built, as I said, on the large language model of SymphonyAI along with Microsoft. But it does get trained and becomes more intelligent on your data as it sits within your environment, within your plants, and uses the knowledge graph and the Iris Foundry underneath it to bring all that data into it and start answering the questions as you do analysis, whether it's on a FMEA or a particular issue that you're facing. You can go deeper and deeper onto that as a part of that. So that's something that you guys will see today in much more detail in the next few sessions. And we're looking forward to talking about that today on these topics. With that, I'll pass it back to them. Thank you.
Thank you very much, Pratik. Yes. Okay, time to announce the next speaker. In fact, I would like to invite Mr. Koen van Kerkhoven, yes, to join us. There he is. Hello, Koen. Koen is going to kick off this afternoon with a wide view on what is happening today in digitization and maintenance, but also then how AI is being applied nowadays. And then from that, we will build on further. So, Koen, I will give you the clicker. For the people here present, there's room for questions, but we will do the Q&A at the end of the afternoon. Okay. So, Koen, please go ahead.
All right. Thank you for the introduction. It's my pleasure to be here today at this event. The subject I'm going to present is digital trends in maintenance and asset management. So not going with AI in the future, but I will show you what digital solutions are now being used in the industry. So last year we did a survey together with Innovation regarding digital trends in maintenance and asset management, and we checked on what the implementation levels were at the industry. I'm going to share some of those, the status and the key insight and some of the learnings that we then transformed in the digital transformation map, or roadmap. And then I'm going to show the key learnings. All right, this is me. So I'm Koen van Kerkhoven, manager at PwC, strategy and operations, mainly focusing on operations management and operational excellence. I worked several years in petrochemical industry, several roles in maintenance and in operations. So in 2017 and 2018, we did as well a survey together with Innovation, and we discussed the predictive maintenance implementation level at that time. So there was a lot of enthusiasm in the industry, and now we wanted to see in last year if there was still that enthusiasm. But now we looked at more than only predictive maintenance. So we sent out a survey to 250 companies. More than 50% responded, and most of the industry, the sectors that they're in are heavy process industry, discrete manufacturing, food and pharma, infrastructure and fleet, and service providers. Now, we didn't only ask questions about predictive maintenance and the implementation level of that, but we also looked at other digital trends, mobile maintenance, digital twin, augmented reality, and 3D printing. Just to give you a definition about these trends, to be sure that we're talking about the same topic. So mobile maintenance is a mobile solution, handheld tablets that the technician can use in the field to check on data of an asset or as a communication tool to the control room. You have the predictive maintenance that uses a technique that seeks failure in patterns and the condition of your equipment. It's useful to do maintenance just in time. It's all based on big data and statistics to increase the uptime of the asset, but also the reliability. Then we have the digital twin. It's a virtual replica of a physical object, system, or process. And it really shows the complete life cycle of an asset. It captures real-time data, and you can do simulations. Very handy if you have new maintenance methods that you want to simulate and see what the scenario is or what the outcome will be. Augmented reality, it's an overlay of information through your real-world view. That can be useful for the technicians and operators in the field if they're working on their pumps or compressors to get some extra information or drawings about the tool, about the asset. And then we have 3D printing, also called additive manufacturing. It's more niche, but it's literally printing layer by layer a 3D model of a certain substance or a certain material. It can be useful if you have a spare part, very specific, and it's not in your inventory. And this way, instead of waiting weeks or months on if you have traditional supply chain, you can just print it on site and use it. It decreases the cost of inventory, but also decreases the lead time. All right, if we deep dive a little bit more and see what the current status is of digitalization adoption in the Northern Europe, we see that 44% of the companies that answered our survey are planning to start or in a pilot phase for predictive maintenance, and 41% is planning or in the pilot phase of mobile maintenance. If you look at the other three digital trends, digital twin, augmented reality, and 3D printing, it's only 20%. Now, what does it show us? That in the industry, companies are really starting to digitalize, but it's step by step. For the lower, the 20% for these digital solutions, most companies that do this are service providers because they see a new business model in it and will push this to the industry. So we expect in a couple of years' time that this percentage will be higher. Now, if you deep dive again a little bit more, but now it's regarding fully implementation, we see that mobile maintenance has 39% in industry, and it's mainly due because it really benefits from 20 plus years of development. Predictive maintenance, 17%. Now, it's interesting fact is it's double of 6 years ago. Then we have the digital twin, 10%, augmented reality, 8%, 3D printing, also 8%. These scores are a little bit lower, and it's due to the fact that, well, digital twin is quite new. You need good data. The data availability needs to be there. Augmented reality, you rely on softwares and hardware suppliers. And we did some tests at PwC, and it's not always very easy to use them while doing a maintenance job. 3D printing is very niche and is specific for industry. Oh, that's a poll question, but we will skip this one. So what do I want to show with this graph is that all these digital trends, they are upcoming. We saw the 39% and the 17%. And what I want to mention is, and it's not on the slide, that in the survey we saw that 21% of all companies are now piloting or doing a digital solution, at least one digital solution. So 21% of the industry of those companies are really implementing at least one digital solution. So we think that in the upcoming years it will increase. So we had overall industry, overall companies. Now we're going to check which industries benefit from which digital solution. So 50% has fully implemented. 50% of the industries, food and pharma, infrastructure, fleet and service providers have implemented and rolled out mobile maintenance. Now for fleet and infrastructure and fleet and service providers, it's quite logical. They're a lot on the road. They're not behind their desk. A couple of weeks ago, there was an internet provider at my home, and he had this mobile solution with him to test the signal strength. Food and pharma, it shows that that we can use mobile maintenance really in a factory setting. The heavy process industry is not on there because it's only 22% that has fully implemented that mobile maintenance. And yeah, I did it a couple of years ago. I implemented handhelds and tablets in a petrochemical company, and with the explosive atmosphere, it's very difficult at ATX1 to well, use that brick of a tablet because it's quite big. If you use it, it's not easy in the field. Now, we also asked, why do you use mobile maintenance? And 72% said, yeah, we use it for work orders, work notifications. And 42% said we use it for inspections and audits and so on. It's always easy if you can take a photo of your asset and put some extra notes there. Very important to note that this mobile maintenance in more than 50% of the companies, it's linked to the company's enterprise asset management and enterprise resource planning. If you look at predictive maintenance, 38% has implemented it, fully implemented it. In service providers, food and pharma, 90%, infrastructure and fleet, 11%. Now, these service providers are most of the time they're original equipment manufacturers, and they focus on one type of asset. So it's a little bit easier to find a solution or to develop a solution for one type of asset. Then in the food and pharma, 90%, they use a lot of standard equipment, and that standard equipment, well, they can use the knowledge of the OEMers to gain information on predictive maintenance. Interesting to note, and I already mentioned it, the implementation of predictive maintenance, it was doubled over the last 5 years, so from 25% to 44%. We didn't only ask, like, hey, companies, what are your fully implementation levels? We didn't ask that. We also asked, what are your primary goals? Why do you do what you do? And what are critical success factors in this for implementing digital solutions? The number one was uptime improvement, and it was followed on a far distance with cost reduction. So they're implementing digital solutions to get better uptime of their assets, but also cost reduction. Now, it was interesting to see that the increase in sustainability was not in the top 3. With the enormous challenges that we have above our head with the reducing of carbon footprint, it was not in the top 3. However, we think due to the regulatory requirements and also industrial peer pressure that this percentage will, that the increase of sustainability will be higher in a couple of years' time if we do the survey again. We asked them what are critical success factors to really have successful digital solution implementation. First, they mentioned regarding, depending on the solution, of course, for predictive maintenance and digital twins, they said, yeah, it's data availability. The data that we have in the company needs to be good enough to do this effectively. Second was support from workforce. So the people that are using, the end users that need it in the field, they have to feel empowered and see the advantages of using that digital solution. And last was skills within the organization are very important. If you're going to do predictive maintenance, you need data analysts and a reliability engineer, of course. So with all those learnings from the survey, we prepared, or we made a digital transformation roadmap because we have a lot of clients, of course, and we come to them and they ask about digitalization. And now and then we have to mention that transforming a paper workflow into a digital workflow is not digitalization. So that's why we made this digitalization roadmap. So we have 6 steps to follow, and we think this is a good foundation to really successfully do a digital transformation and implementing the digital solutions. So the first step is setting up the digital team. So you have a digital team in your maintenance and asset management department, and it's over all the layers in your department. So you can have a mechanic engineer, but also mechanic, IT, OT engineer, asset manager. And it's very beneficial to also search in the HR department or procurement to have some general roles so that you have a broader scope. The end result of step 1 is having a high-level project plan for the following 5 steps. Then we go to the second step, develop digital maintenance and asset management strategy. So you have to analyze your current situation in your company. So you'll have to ask a lot of questions to yourself from, okay, what pilots are we doing right now? What are we doing in the digitalization sphere? But also what IT/OT infrastructure do we have? What is our overall maintenance and asset management strategy? And how can we create value to the company when we do a digital maintenance and asset management strategy? That's more top-down, but you also have to go to the shop floor, to your operators and technicians, ask them, hey, what do you see? What is a good requirement for a digital solution? Because the end user have to use it, so they will have good insights on the strategy. Now, after those internal analysis, you start internal strategy sessions, and you can benefit from best practices in the industry. And with those both, that combination, you will. That's a good basis for a digital maintenance and asset management strategy. Now, the digitalization and implementing that digital solution really has to benefit the overall strategy of maintenance and asset management. So the end result of this step is an implementation roadmap, but also a various. Okay, I hope that the people at the back already heard me. Can't start over. All right, where was I? So developing the digital maintenance and asset management strategy. So as I said, internal analysis, ask yourself a lot of questions. What are we doing here and where do we want to go in our digital solution implementation? The end result of step 2 is the implementation roadmap with various strategic initiatives over time. We go to step 3, it's building the foundation, like creating an overall governance. We see that a lot of companies skip this if we have conversations with them. And it's because if you do a digital solution and you implement it, yeah, there will be new work procedures, there will be new ways of working, and not only new ways of working, also new roles and responsibilities. As I mentioned, for predictive maintenance, you need to have a reliability engineer, but you also need to have a data analyst to analyze the data. Next to that, you need to have a well-configured enterprise asset management system or enterprise resource planning to have the data available. And then talking about the data that you have needs to be good data. If you have the wrong PNIDs or PNIDs of 10 years old, if you have the mobile maintenance and you want to do a work notification and you upload a PNID of 10 or 15 years ago, yeah, that's a disaster waiting to happen. So overall, you will create a change plan in this step with all the requirements that you need and all the changes. And not only that, you also look to your leadership to have the commitment to really implement these digital solutions. Step 4, selecting the digital solutions. Most companies start with this. So based on step 3, you already have a scope and you have the functional requirements for an application. Do you want to develop it yourself? Do you want to buy it off the shelf? And there are a lot of software solutions and suppliers and hardware suppliers. However, you have to keep the end in mind. What do you want? What's your business case? And also the effort that you want to put into it. Are you going to do a small pilot? Maybe it's easier to buy a off-the-shelf solution and go for that. You can take those functional requirements and share them with your IT procurement, and they can start a tender or the request for proposal. But in parallel, you should already design your IT and OT infrastructure. Now, the end result of this is a detailed project plan for the pilot and the rollout. And this also needs a cost and benefit analysis. Luckily, you have a rigorous structure, a step-by-step that you follow. So for the costs, you already know it's step 3 and step 4. And the benefits, normally you have in step 2. So if you have a good business case, you can go to the pilot phase, launching a digital pilot. Now, that pilot phase is like a proof of concept to check with all the internal discussions that is going to work and that you can create value for your company. I would say, I did it a couple of years ago. If you do the pilot, keep the scope narrow and don't don't do the whole plant, or if you're a site, don't do your 12 or 50 plants, but check one production line, take a maintenance team that has a high change readiness, that's really empowered and wants to work with those new solutions. It's also very important to accept failure. It needs to be in the change plan because you will have bugs and you will have errors when you're using, for example, mobile maintenance. Then the last thing you do in this step 5 is really evaluate how it worked. And if you see that it goes well and it's you have a positive feeling after it, you can go to your step 6. That's scaling and accelerating and really create value for your company. So that's the rollout phase. You can do it on 2 axes. You have the axis on asset level. So you do it for one type, for example, predictive maintenance only for your pumps or only for your compressors. Same with the digital twin. Or you can do it on the axis of the organization. So roll it out through your plant or your organization. For mobile maintenance, this can be a good idea. I would say take small and manageable steps, and after each steps you optimize, you evaluate, and then you go forward in your rollout. And very important is you have to monitor and measure to be sure that it's a success. And I don't mean only in your uptime and cost reduction or savings, but also on your safety, for example. These are also important to check if it was a success or not. So normally what's also important is the workforce. If they feel that the digital solution works, your solution will be very good implemented. As, for example, if you buy 50 tablets and handhelds and they're in the closet half of the time, you know that your digital solution didn't work out. All right, so the closing status, what are the key learnings of our survey is that the implementation levels are still quite low. However, companies see their value added. Do not overvalue the business case. I remember from when I was implementing that mobile maintenance, we saw that top management said, yeah, it will create a higher efficiency, more speed in the maintenance. However, what we saw is it was not the speed, but it was the quality of the data and the quality of the work that improved. Now, it's always great to enroll a new tool, but you need cultural change. The workforce needs to be there. They need to use it, and they have to want to use it. I always say creating a culture takes time. However, if you create a good climate for it, it will in the end work out. Define a roadmap, like I tried to explain on the last slide. If you have a good, rigorous structure, it helps to successfully implement your digital solution. And there's still much to win in the field of digitalization. So yeah, these are some of the people that worked on the survey. So I want to thank you for the attention. And if you want more information about some topics, please feel free to ask me a question during the break or at the networking event.
Thank you very much, Koen. Okay, so time to go to the next presenter. Hans Verbeek of Microsoft is going to talk about AI in industry. So we're making the switch from digitization towards AI. So Hans, I will give you the clicker. Here is the microphone. Please go ahead.
Thank you. Good afternoon, everyone. I'm Hans Verbeek. I'm a technology manager at Microsoft. I manage a team of cloud solution architects, and we're all into AI. I started myself at Microsoft, I think, 22 years ago. Then in 2017, I left Microsoft. I became the CTO of Nextport, a startup in the context of the Port of Antwerp. And in 2000, I rejoined. And they call me now a boomerang, and because I went away and I came back, and I'm really glad I came back, because I think that today, with AI, as a hyperscaler, Microsoft, in my opinion, is more relevant to our users than ever before. And I want to show you that with AI, this impact that we're having is even increasing. Microsoft has had an AI platform for a long time already. And we had a platform on which we needed data engineers and we needed data scientists. And what they would do is they would collect data, they would tag data, and then they would build a model for a very specific use case. A very specific use case for predictive maintenance, or for instance, to detect sentiment in texts. But these are all very specific use cases with very specific models with very high precision as well. Now the world has also come to know another model of AI, generative AI, in which the foundation models actually play an important role. And I think we've all seen ChatGPT being introduced to the world, and then everybody understood that GPT is one of those foundational models. And these models are not trained for one specific use case. They are trained on a massive amount of data, and out of that technology, the transformer technology, then a number of abilities arise in these models. And this is a world in which absolutely scale and size matters. So let's talk a little bit about GPT-3. I'm not talking yet about GPT 3.5 or GPT-4, but GPT-3 had 175 billion parameters. This is a huge matrix of words that are connected to each other with a weight, a number. And why does size matter? Well, apparently, with the transformer technology, the more parameters you add, the more abilities come to existence in these models. For instance, multi-step reasoning, chain of thought reasoning only comes to existence starting from a number of billions of parameters. A second reason why size here matters is because you've probably noticed that a lot of these companies, such as OpenAI or Mistral or Anthropic, they start linking themselves, they start creating partnerships with large cloud providers such as Microsoft, AWS, and Google. And why is that? That is the case because training these models is extremely compute intensive. To give you an example, GPT-3 with 175 billion parameters, it takes the 5th largest supercomputer in the world that Microsoft created 9 days in a row to pre-train it. It needs to run without error for 9 days in a row. The cost of one run is $4.6 million. That's how much it costs basically to pre-train this type of model. It's an enormous type of compute need that is existing out there. Just as an example, if you would invest in your own desktop computer and you would put in a nice NVIDIA GPU card in it, an RTX 8000 card, you would pay 3,500 euros just for the card. And you would want to pre-train GPT-3, it would take your computer 665 years. Who has that time? Nobody. And that's why we actually do have these partnerships between companies such as OpenAI and Microsoft. Actually, just one more number, I think this is really mind-blowing. Our brains, if you would, we have about 80 billion neurons in there with 7,000 synapses each. This would translate in a 60 trillion parameter model. 60 trillion, and we run that on 30 watts continuously. So we are still very efficient as human beings. I don't think we're being threatened just yet, but I still think we're doing exceptionally well as a species. So out of these models, you get a large language model with some capabilities on knowledge and some capabilities on reasoning. The knowledge is in there. The knowledge based on the text that it was trained on is in there, but it has mostly also reasoning capabilities, which are kind of mind-blowing because that's what makes them approach the way a human being actually works. Now, OpenAI, we have a very intensive partnership with OpenAI. Their goal is to build the smartest thing that they can build as long as it benefits humanity, fortunately. So our goal at Microsoft is a little bit different. We want to make every person and every organization on the planet more productive. We want everybody to achieve more. But we believe that with artificial intelligence, we can actually do that. And the adoption of artificial intelligence, and more specifically generative AI, has been nothing short of spectacular. Here we see the amount of time that it took a technology to reach 100 million users. And for ChatGPT, this was 3 months. For Facebook, this was still 4.5 years. Also, I think for those who have followed the news, a day before yesterday, there was a study here in Belgium from UGent and from IMEC, showing that also adoption in Belgium for GPT has gone extremely fast, faster than any other technology before. Now, it's not just about adoption, it's about the economic impact. We believe that AI has come out of a winter, and the economic impact of AI will actually be a multiplier, an accelerator, like we've seen, for instance, with steam engines, like we've seen with the internet, like we've seen with mobile phones. This will be an accelerator for the global GDP, like those types of technology. So we shouldn't compare it with Facebook, actually. We should compare it with one of those technologies that meant a fundamental shift in history in the world. And that's why we are very bold. It's also typically Microsoft. It's a little bit our culture, I must admit. But we're very bold. We're always betting. We're always going all in to certain technologies. And here with AI, we believe that there is no individual, there is no team, there is no company in the world that will not be impacted by this technology of AI. And we want to help all of our users, everyone who works with our technology, with finding the road to take, because we do acknowledge there's still a lot of fog. Is the technology ready? Can I use it in my business context? Is it going to make up data, for instance, and going to produce incorrect results? There's still a lot of fog around it, and we are here actually to clarify that road for you. So our approach to this is quite simply the following. So we, first of all, we want to work at that bottom level, at the level of the trust. If you do not trust the platform with your data, you will not adopt AI. That is very clear to us, and that's why we have, I believe, a nice technology stack that gives you some of that answers. I'll come back to that in a moment. We also will build a co-pilot for everyone. Everyone here will get a co-pilot. Either we build it or our partners such as SymphonyAI will build it. But everybody will have access to multiple co-pilots in their work environment. And we also want to be a platform company based on which you can build your custom solutions. Microsoft can only build so much. We're a platform company, for every industry. But you as a customer have very specific needs. You can actually build solutions towards those needs as well. So first of all, trust. This is the foundation layer. The one thing that we promise is your data is your data. Whether you bring it onto our cloud platform for an AI-related purpose or for other more transactional types of systems, etc., your data is always your data. It is stored for you. It is not shared by anyone else. We do not generate insights on top of it. It is your data. And more specifically on the AI topic, this is really important because we guarantee that we will not use your data to generate the next version of, for instance, GPT, of a large language model. And that is a guarantee that you do not get when you go, for instance, to ChatGPT online. Because I know a lot of you are probably using ChatGPT online. And there's this case from Samsung Semiconductors, for instance, where they know that some of their employees actually used some of their code that they use to detect defects in their semiconductors. And they pasted that into the ChatGPT window. And by doing that, that will become part of the knowledge of the next generation of model. That's something you want to prevent. So what you can do on our Azure platform is you can deploy GPT just for your organization. Within your boundary, you can deploy it in EU data centers so that you are GDPR compliant, and it is basically shielded just for you. And that's already an important guarantee that we can give you. And then, of course, you can protect it with encryption. You can bring your own keys. You can make sure that your prompts that your users send don't go over the public internet in an unencrypted fashion. All of those tools are available for you. There are two more very specific generative AI-related concerns that our customers have. First is around information integrity. I think we're all sometimes spending some time with ChatGPT trying to get it to say something that isn't really, clean or allowed or whatever. We all try to do that. We try to make it say something funny. And then the next thing you think is, well, I cannot do that within my corporate context. I cannot do that for my work. So can I use this technology for my work? Well, we have a responsible AI standard that is not only a document with words, but also consists out of tooling, etc., that allow you to tune these models so they are professional, avoid discriminatory content, for instance, so that they avoid the topics on violence, etc., so that their creativity is a little bit lower, but their precision is much higher. We provide you with the tools to make sure information integrity is guaranteed. Then the next thing that we have is, what about contractual indemnity? What about the content that is generated with these models? Can I use it? Aren't there any IP rights on them already? For instance, if I generate code using GitHub Copilot, maybe there is some open source license on top of the code. Well, we guarantee you that this is not the case. And if you would find yourself challenged in front of courts, then Microsoft will stand by your side also with financial support. So that is something that is very specific to AI that we need to do at this time in the world, at this time with the state of the technology that it is in today. Copilots, I think you will hear a lot about copilots, custom copilots, but also Microsoft copilots. So we are actually building a copilot, which is a digital assistant that is basically AI powered. We're building that for everyone. So you can chat with your data using natural language. So you can actually use it not just to summarize or to generate an email, but also for more complex tasks. You can actually have it think about the stuff that you are missing in your train of thought. You should really use it as a professor, as an assistant professor sitting next to you all the time, that you can challenge and that can complement you in your thinking. So what we've seen when we've deployed this technology since September at our customers, we've seen some tremendous numbers, actually. We see that people are spending a lot less time looking for data, and this is typically data within their corporate environment. The people are today, when you need a piece of information, you first need to know, where is that information going to be? Is that going to be in my HR system? Is it going to be in SharePoint? Now you can just ask for the data. 71% savings on mundane tasks, such as writing emails, 3.5 times faster catch-up on emails, and I'll show you how I do that, for instance, and 1.2 hours per week saved on average. 1.2 hours might not seem like a lot, but it's already a good value proposition. Microsoft doesn't give away software for free, and especially not software like this that consumes quite a lot of compute and power, etc., which cost a bit of money to run. So we charge our customers $30 per user per month. Now, if you can save 1.2 hours per week, then obviously the return on investment equation, let's say, becomes quite interesting. So how does this work with Microsoft 365 Copilot? This is not just ChatGPT that chats with your email. It is actually the model, the large language model, that understands what data that you are working on, because whenever you use Microsoft 365 in Outlook or PowerPoint or whatever, in the Microsoft Graph, it keeps track of what you are working on, who you are working with, when you were working on the content, etc. All of that information is actually tracked in the Microsoft Graph, and the Copilot uses that information to provide you with very context-specific support. Also, the Copilot can connect to the internet, so it is not limited to the knowledge inside your corporate environment or and inside your SharePoint, etc., or the knowledge that was already in the model. It actually also uses from the internet. So here, let's see. Here, this is my actual personal Teams environment, my production environment. And here I'm going to catch up with a meeting. So what I used to do is I would scroll through all the chats to find the chat about the meeting. And then I would try to figure out whether actually that meeting had a recording or had a transcript, or whether the files were shared, the Word documents or the Excels were shared. And then I would try to dig a little bit deeper. This is no longer the way I work today. Today there is a Meet app in Teams. So when I click on Meet, basically I get an overview of all of the meetings that were in my calendar in the past. And for all of those meetings, you can easily see, were there documents shared? Was there a transcript made? Was there a recording made that is now available? This makes it so much easier for me to find information. And for instance, here, there's a Western European Managers Update meeting that I actually missed. So I'm going to catch up with that meeting. And when I want to catch up with that meeting, I can easily see the recording, but at the bottom I see who was speaking when. And I can also switch that view, for instance, to topics. And when I switch to topics, I can basically see which topics were discussed when during this actual meeting. Now, this is interesting, but what's even more interesting is that on the right, you will see that there is content generated by AI. And so you get a little bit of a warning, like you need to check whether it's actually true. But there are automatically meeting notes generated from this meeting. And not only meeting notes, also follow-up tasks. And one of the things is there's an offsite in Madrid. Now, I love to go to offsites in Madrid personally, so I would like to find out a little bit more about that. So one of the things that I can do is either I can play the topic in the recording, or I can click on Copilot, ask them what is happening in Madrid, and then I get the information like, there's something happening in Madrid, April 8th or 10th. You need to do the booking. This is what we're going to be doing. Apparently, there's a dinner there that I do not want to miss. So, and beauty also here is that there's this 1, 2, 3, 4 buttons at the bottom. The beauty is that I can click on that, and then I see the actual words that were uttered by the people in the meeting based on which this summary was actually being created. This way of catching up with meetings is so much more powerful than the way that I used to do it. And for me, this already makes it worthwhile having this introduced in my environment. Actually, one of the changes that we'll introduce is that today, if you get a meeting request, you can accept it, you can say maybe, or you can decline it. In the future, you will also be able to indicate, I want to follow the meeting. By doing that, the meeting organizer knows that you will not be there in person, but that you will catch up later through this tool. So they will start the recording, etc. And so that you can safely actually accept multiple meetings at the same time, not accept them, you accept one of them where you will actually show up, and the other ones you will follow. So this is something that we will make as a change in Outlook, for instance. So this will make it a lot easier to catch up with meetings. So what happened here is actually a full pattern that we call reality augmented generation. Oh, let me go back one slide. Yes, reality augmented generation. Why is it reality augmented? The large language model in itself doesn't know nothing, fortunately, about your emails, about your calendar appointments, etc. But when we as a user in Outlook or in the Copilot ask it for something, it is first going to rewrite my prompt. I will ask it, for instance, which appointments did I miss, or what emails did I miss, and summarize them. The prompt that it will send to the large language model will be much larger, because the prompt will be something like, you are a professional assistant, you want to give professional answers, you will not make up stuff, you will only base your answers based on what you find actually in the Microsoft Graph, etc. So all of that is written in a prompt that you do not get to see and do not have to write. But once it then gets that information, it uses not only the reasoning powers of the model to, for instance, say, these are your tasks, but also the language powers, for instance, to say, this is the email that you want to write, or this is maybe the code that you need to manipulate your Excel file so you can insert a graph or something like that. This is reality augmented generation. And this is a pattern that also in the SymphonyAI tools, they are actually using to make sure that the model isn't just making up stuff, that it's actually doing something with your real data. This is really important. And we have co-pilots all over the place. We have them in Microsoft 365. We have them for developers in GitHub Copilot. We have them for our security professionals. We have them in our ERP and CRM systems. So we have already available, live and available, all of these co-pilots across our platform. But of course, not everybody, not every user is only working in Microsoft 365 or in Dynamics 365. You also use other tools, such as SymphonyAI or other tools, an MES or whatever you have in your environment. And we also want to be the platform for that. So in this case, again, what we're mostly interested in is the reasoning capabilities of these models. And so what we allow you to do is the following. You can take a large language model, and the large language model has certain skills and it has a certain knowledge. And large language model is trained, for instance, up until September of last year. So they will always have a moving date up until what point in time they were trained on a large data set. But of course, you can actually extend that. And the Microsoft Copilot, for instance, does has with the Microsoft Graph knowledge, and the skills are extended because the Copilot can manipulate Word documents and PowerPoint presentations and so on and so forth. Now you can start extending that by using our Copilot Studio. And you can then create additional plugins, and you can connect additional data sources into this environment so that your user can actually go, for instance, to the Copilot and, for instance, ask a question. Let's say they're a salesperson, they could ask the question, what are my open leads? If you're an employee, you can ask the question, how many vacation days do I have left, or what does my employee profile look like in the HR tool? So without having to go to the HR tool, you can do this in your Copilot environment. For invoice management, supply chain, you name it, whatever domain you have, if you can couple your data into the environment, you can actually approach it from within the Copilots that Microsoft provides. But then, of course, and we've already seen it very briefly, you also have your apps that are not the Microsoft 365 apps, and also there you want to chat with your data. This is where, for instance, SymphonyAI use case comes into place. They can actually build from scratch Copilots and show them to you in any environment. And we have a very detailed platform for this with technologies such as semantic kernel, LangChain, etc. It gets very techy right there. But we have the platform for you to build also from scratch. Now, the one thing that I want to say to conclude also here is that data is really the fuel. Data is the fuel, because if you do not have a data platform that allows you to create a place where you can have AI technologies interact with your data, then you will not see any benefits, or not see the benefits that you probably are going to expect from this technology. And so technologies such as data lakes, etc., become really important, and they become like a prerequisite for your success with AI. If you're today living in a data swamp, then you better get that swamp cleaned up and get it into order with technologies such as, again, allow me to say, we believe we have a very scalable data platform for you. We have technologies such as Synapse, such as Microsoft Fabric, etc., that actually allows you to bring a lot of data in a very scalable way, in a very governable way also, to a place where it can interact, where you can interact with it by using these AI technologies. Because one of the things that our customers always fear is that when they introduce generative AI, chat-based technologies, that they are actually organizing information oversharing. That's what they fear. And I think the fear is right, because the first question everybody types is, what is the salary of my boss? And then you give, in my case, is it Eric Kerikhoff, what is the salary of my boss? And in theory, if of course the model would have access to that information, maybe it's stored somewhere in a SharePoint that I don't know, but the model through the graph has access to it, it could actually find that information for me. I do no longer need to know where to look for it. The model looks for it. Now, the good news is that the Microsoft 365 Copilot, fortunately, it respects all of the boundaries that you created between your data stores, let's say, whether this be a SharePoint or something else. It respects that. So it will only give you access to the information you already had access to. But even then, for some organizations, this is not that well organized, and maybe people just don't find that information because they're not that tech savvy and they don't know the URL of that SharePoint where that information could be found. And so today, paying attention to your data platform from a scalability perspective, from a data security, data governance perspective, is absolutely critical. And then, of course, you have very specialized data platforms, such as the one from SymphonyAI, that actually do that for your specific use case as well. I'm talking here about more general types of use cases that apply to all types of industries, but our partners actually can make that very specific for you. But this is absolutely paramount. Once you have this type of a platform, then you can actually start seeing benefit from this type of technology for your specific use cases. And we, as I said, every team, every department, every organization in every industry, but also specifically for manufacturing, there are actually use cases to be found everywhere. Whether you're talking about product design cycle acceleration or supply chain optimization, smart factory operations, if your people can use their natural language to interact with all of that information that is available, which is probably too much, and they can use the reasoning capabilities in the model to assist them with what they're missing in their own reasoning chain of thought, if they can be really assisted, they're going to be more productive. So for your different personas in your organization, and I think partners like the ones that we already heard today, they can actually help you with discover use cases specific to you. But let's say that you're responsible for plant operations, create a summary of operational performance over a prior period, request recommendations for performance improvement, summarize daily ops meetings with actions and owners. These are tasks that you're doing today and that you can actually become much more productive at. So the opportunity, and again, this is a bit Microsoft culture, we're very tech optimist, but the opportunity, according to us, is clearly there, but we will need to capture it together, because it's only when we make your use cases a reality, when we get you to use these types of technologies on your data, it's only when that happens when it becomes really relevant to you. And maybe one final thing that I also want to say is, it's not like this generative AI is going to replace the machine learning type of AI. I think when you combine the strengths of both of them, of very specific models with more generative, generic type of models, it's when you start combining those, and when you teach also your users on how to then get the most out of it, that's when we also will see a lot of value. Because teaching your users and changing your culture to be more of an innovative culture in which AI takes front center, this is going to take a lot of effort. Also for myself, I love the technology, but also I need to sometimes force myself still to use it in specific cases. And I think that's, we're all human here. There is something that sometimes I say, like, you need to do something for like 20 days in a row before it becomes a habit. And I think that's also the case even with these technologies, even though the benefits, the productivity gains are quite clear. So the opportunity is ours, but we will need to invest time in it, and we will need to be smart about the way we want to adopt this. With that, thank you very much. Thank you.
Thank you very much, Hans, for this inspiring presentation. So now it's my pleasure to introduce you to the next presentation. We're going to talk about the next generation smart industrial platform, generative and predictive AI. And we have, in fact, two speakers. So we have Mr. Sudeep Govindshankar, yes,
and also you, Mr. Srinivas Kupa.
That's right.
Welcome to join us. I see that you have both microphones, so that's very good, and I will give mine to the host. So
Thank you very much.
yours.
Thank you.
Please go ahead. So
All right.
it's the final presentation before the break.
Thank you very much. I hope you all are going great again, right? 3 sessions, 3 more sessions are coming in. So you heard a lot of terms in here, right? The digital transformation, you heard data, you heard AI, generative AI, assets, process, industrial, a lot of terms, a lot of technology, and a lot of exciting stuff, and how a lot of the manufacturers are using this to generate value. At the end of the day, if you're an end user, a manufacturer with whom we work all the time, your basic question is, how can I put all this together and bring it for my end users to perform better, get better results? If that's the question you're thinking about and solving your basic problems, the next 3 sessions really try to achieve the goal. At SymphonyAI, we talk about assets, processes, and people on the manufacturing shop floor, as well as the field assets, and how we draw value by applying the technology. Okay, so that's what you're gonna hear in the next 3 sessions. The great part of these sessions is it's not just about slides and conversation in terms of what can be, but exactly what it will be by showing the platform, okay, and the capabilities. So before I go further, I'll introduce myself. Of course, I have been introduced, but I'll do that real quick, and then I'll introduce my colleague. I'm Srinivas Kupa. I'm the Chief Strategy Officer for SymphonyAI Industrial.
And I hope you can hear me. I'm Sudeep Gauri-Shankar. I'm Director of Product Management for the AI products at SymphonyAI.
Okay, I'll build it up. So a lot has been discussed. I'll go through 2 slides, and then right away Sudeep will jump in, start doing a very hands-on approach to showing the areas, right? So when we talk to a lot of manufacturers, and we work with a lot of the assets, processes, and people trying to help them, as it's being heard from a few of our partners here as well, every manufacturer is in a certain stage of the digital transformation. Some of them are really trying to take the paper-based, digitalize it, and try to use more process-driven approach. Some of them are really on the other end of the extreme, trying to really use these advanced technologies like Copilot and how to really draw autonomous operations of their warehouses and plants and asset performance and so on and so forth. So the technology that we're bringing to the table for the manufacturers, we call it the Iris Foundry. It can be deployed on the cloud on our friends Azure's platform, as well as on premises. Really enables any of our customers, wherever they are in their path of the journey, to be able to pick them up and really accelerate their digital transformation wherever you are in this so-called maturity curve. So you saw Prateek talk about the copilots, and you saw that little video where the interaction was happening, where the end user was communicating with the copilot and trying to get the insights out. What we do is, as you start looking at Sudeep's presentation on the digital transformation, starting from really where the data source is, taking the data, transforming the data, applying the contextualization around the data, and really enabling that data to perform certain actions for you as the end user is really critical. So what you'll start seeing around the journey part of it is, it's great to have an interaction model in here, but whose life are we improving by offering this kind of a technology? At SymphonyAI, it's all about the end users and their value proposition. If you look at the right-hand extreme, you look at the operator, the quality analyst, the production manager, maintenance engineer. These are the key personas, right all the way up to the plant manager, the director of operations, in some cases, VP of operations, really looking at their operational capabilities of their assets, product going out, of their processes, and so on. Everything that we apply at the platform level, bring your data together, is to really enable a better performance from your end users. So once again, before we jump in, it's all about the data journey to draw the digital transformation and then bring it to the end users to drive the ROI for you. Sudeep, with that.
Thank you. All right, so what I'm going to go through today is actually just a live demo of all of these different pieces that you need to enable solutions like you've seen today. Right from your your plant, you're collecting data, you're collecting different types of data. And then you are, have to sort of consolidate that data, you have to integrate that data. You have to store it in a form that you can actually use. And that's really just the first step, where you're building these pipelines, where these pipelines are correcting the data, they're looking at whether certain sensors are faulty, whether there are aggregations you have to do on certain pieces of data. And of course, you have to also contextualize that data. And what I mean by contextualize is that you have to add enough metadata or context to each and every data point such that you understand what that data point means. And remember, the whole goal of this is to enable very high levels of automation in terms of your analysis. So that automated system has to understand what that data point means, what each data point means. And it's not just about each data point by itself, but it's also about how each data point is related to other data points. So to give you an example, let's say we have a centrifugal compressor. And this compressor has a number of different sensors on it. It has flow sensors, pressure sensors, probably has temperature sensors, and so on. Now, this particular centrifugal compressor is an asset within your facility, right? And now you have this data that's coming in, it's sitting somewhere in a database, for example, and you're trying to do some analysis on why that centrifugal compressor is not performing as well as it should be. At this point, very often you need other information. You need information of, hey, when was the last time this compressor was maintained? By whom? What was actually done? What was, the last vibration report saying, right? What is the oil analysis saying, the last one that we had? How does this all work together? And so there's always somebody at a plant who has this understanding, this very sort of deep understanding, but also very broad, to triangulate and say, you know what, based on everything that I'm seeing here, we think this is the issue and this is what we should be doing. So that is the level of context that you need to, actually find out what a problem is and then actually take action. And so what we've also done here is added a knowledge graph. Now, the knowledge graph is a concept that's been around for a while, but now with the advent of predictive AI, as well as new technologies around data management and the large language models, these knowledge graphs have become very, very useful, because the knowledge graph is able to tell you right from a single point when you start your analysis, it's able to dig deep into all of your other data sources, and it's able to find that contextual information to actually give you that full picture. This was not really possible very easily before. You have to build pretty complicated software, intelligent software, to be able to do this. So that's all about context. It's a really important piece of what we're doing. And then is where you're ready for modeling. And data modeling, of course, modeling is a very sort of broad word, but the way that we're using it over here, it basically means that you're either building models using data, or you're also, the other meaning of data modeling is also that you are storing data in a certain format after certain transformation, so that you can use it more easily for your analysis. So in the data modeling piece, you of course have to be able to explore your data to see it in a convenient form. You may have to build digital twins, for example. So these are database models that capture behavior of assets, of processes, of entire facilities sometimes. And these digital twins can be used to simulate scenarios, forecast into the future based on current state. They could also be used to just explore what's going on in the data. That's another type of digital twin. And data modeling, the final piece that I have here, let's see if this works, the industrial large language model. So we heard about large language models, how it's really proliferating the number of use cases that we have, the industrial large language model is something that has been fine-tuned on industrial data sets so that you get very specific industry specifics answers from this model. So to give you an example, the industrial LLM here can answer a question on what a potential mechanical failure could be based on the input of the latest vibration test that you may have run. So you may say something like, there's axial vibration that I saw at this level. I saw some other sort of features in my vibration based on this kind of asset, and it'll actually give you diagnoses and saying these are the possible issues and these are the possible things that you should be doing as recommendations. So that level of depth of understanding of industrial concepts, the physics of industry, that's something that you're not going to find in a general ChatGPT or general large language model, but the industrial large language model is built to be able to do that in depth. And finally, insights, and this is what everyone consumes. These are end user interfaces that everyone has to use. This interface could be a copilot, like a chatbot, like you've seen, but they could also be other interfaces that you're used to. They could be dashboards, they could be alert management systems, they could be different types of ways to explore your data and explore the results of your analysis. And this whole process that I'm showing you here, of course, something that underpins this is the data governance, right? So this is obviously very important. This is something that lets you trust the data that you have, make sure there's no duplication, make sure there's no garbage that sort of builds within your data stores, and that's very hard to clean. So data governance is, of course, a critical piece of this that underpins everything. So going through this process and building the right set of tools for each of these is really important. And it's really important because you can do one or two use cases without any of this. But when you want to scale it from one pilot use case to across a plant and then across an entire enterprise, that's very difficult to do if you don't have the right set of tooling in this format. So just to give you an example of what a platform that would have all of this would look like. Maybe, I don't know if people at the back can see the text, so I'll just sort of read from the bottom up to the top. So the bottom is all of your different data sources. Here we have enterprise data, operational data, engineering data, other types of data as well. You have to connect to those and bring them into some sort of data lake. I think we heard about data lakes just now as well. So this data lake is not only storing your data, but it's contextualized before it's stored. And that lets you easily ask for the data that you need without knowing the specifics of how a data is stored within a database, which table, which column. Those things cannot be tribal knowledge. You have to be able to ask the questions based on what you know. And you may only know the asset name, for example. And I want all the bearing temperature data for this asset that sits in this facility, and you should be able to get that. That's how easy it should be. So that's what the data lake is all about. We talked about the knowledge graph. I'll talk a little bit more about it as well. This is something that sits on top of your data lake. And then there might be foundational AI models and also large language models that might be part of this platform. And the reason you need these is because the machine learning models, for example, if you just go online and do a Google search, you'll find lots of open source machine learning algorithms. And you'll find different types of LLMs as well. However, not all of these can be applied readily to the problems that you want to solve. And often there's a little bit of plumbing that you have to do to actually get these to work. So to give you an example, if you're if you're trying to, let's say, do some sort of anomaly detection on, like real-time anomaly detection, let's say, on a gas turbine, right? Now, the open source algorithms might let you bring in any sort of data. It might let you train a model, and then you can run it, and it'll work perfectly fine. However, what we've found in our work is that the gas turbine is a complicated piece of machinery, and there is physics involved in there. There are certain constraints that you have to actually follow. Not all answers are going to be correct, but data can be sort of crunched and you can get an answer, but how do you actually trust that answer? And so some of the foundational AI models for an industrial platform that many of you might be looking at, though these models can also be augmented with sort of physics constraints and thermodynamical constraints, so that the answers that you get are also something that you can trust and something that you can understand. Often AI models can also be very black box-like, where you don't know why a certain answer has come out. So explainable AI is also really part of some of these curated and engineered foundational models that might be in a platform like this. Of course, I talked about the industrial large language model, so that's in there. Another thing I want to talk about is the comprehensive MLOps platform. So this is a capability that you definitely need. MLOps stands for machine learning operations. Machine learning operations is really the way to organize and maintain all of your AI models that you're going to be building over a large period of time in a large organization. You need to be able to see how these models are performing and maintaining them over time as well, because they will drift over time and then they become useless. So how do you enable people in your organization who may not be data scientists, who may not be data engineers? How do you enable them to easily manage this over time? So you need the MLOps platform that's made for a citizen data scientist or a subject matter expert or a maintenance engineer to still be able to use. So that's something that would be useful in a platform like this. And right on top over here, this is your use cases. Some platform like the one SymphonyAI has, there are applications that are already pre-built for common industrial use cases, like asset performance management, for like connected worker, like manufacturing operations management, and so on. But of course, there will be a lot of custom applications that you have to enable your organizations to build, because you know your organization the best, you know the problems that you're facing the best. And the whole idea of a platform like this is that you are empowered to build the solutions in a way that will actually scale without having to deal with the immense complexity of the software that's required to enable it. So that's a quick overview of what this whole platform is. And what I want to do now is actually show you some live demos of certain parts of this that are important. And in a subsequent session after our break, we'll actually go into some of the end user applications as well to give you a flavor of what output you get out of this whole process.
Yeah, so just like to highlight a couple of things that he said as he sets himself up, right? A lot of the people do things, science projects, getting a bunch of data scientists coming in, wrangling with the data, getting the outcome. But we have seen the proof that after a POC being done in a corner of a plant, it never scales. There is adoption side of it. There's a change management side of it from the manufacturer side, but however, the technology is a challenge as well. How can you build a technology that can help you scale, add use case after use case, add a data source after data source, and do it in a much more effective way where you don't have to engage as a manufacturer, an army of data scientists on your end, but rather use a platform to start getting the end user value. So that's the highlight of it. So, yep.
All right, great. Okay, so the different steps that I showed you. So the different steps that I showed you, they're sort of represented on the screen. There's data orchestration, data contextualization, modeling, insights, and governance. And the tools that are required for each of these. Of course, there's other tools as well that you might need. Are you able to see the color?
No, it's blanked out. So just this is the actual application. It's a browser. Abilities that are there on the platform. So of course, not a single user or persona or a role company would end up using all of it. So it's a role like he said. So depending on if you're a process engineer, an admin, or an end user like an operator, different information will be turned on and off for you to perform your tasks. But because he's demonstrating the whole capabilities of the Iris function, we're really helping you walk through from picking the data from a data source all the way to drawing the value insights.
So we'll start off on the data orchestration side. So the first thing, of course, is that you need to be able to connect to different data sources. So, if we I'll have to switch a little bit here. Okay. So just before I get into the live demo, I just wanted to sort of talk about one way of connecting your different data sources. So you're going to have data sources like CMMS system, ERP system, historians. You may have MES. You may even have, of course, you also have PLCs and SCADA systems, and you may want to be collecting data from all of those. And these systems, they are going to be in, let's say, your OT network at different levels, and a data platform like this may not necessarily have direct access to a lot of these data sources because some of these data sources are, part of your control architecture. And so, there are certain agents that you deploy. They're depicted here as data connectors, and all of that data goes into something like a landing zone. This is a typical architecture that we've used and many other people have also used. So this landing zone is essentially where data comes in raw, and then you have a transformation pipeline that reads that data, consumes it, and then transforms it into the form that you need to actually store into your databases. And of course, this transformation pipeline can also add context to that data. So you can set up all of that so that all the new data that's also coming in is getting contextualized as it's coming in, and this data might also be getting corrected. You might have imputation where you have missing data, or you have a certain sensor that suddenly goes offline. So that's where this part comes in. So you need the capability to read write with multiple data sources. You need a live pipeline to sort of stream that data in real time if you do have real time use cases. And the contextualization and pre-processing should be flexible, because today you're going to think that you have certain needs, but tomorrow you're going to have completely different needs. You should be able to add another pre-processing step, or completely remove it or change it. So that is really, really important. Is something that we have seen. And of course, you need the ability to control all of this through user interfaces, because not everyone is a data engineer in your organization. So everyone really should be empowered.
So just to add to that, right? I know a lot of systems can connect to the data sources and pull it together, but what we built in is what we call as IoT gateway. When you're living really at the plant level, you have a lot of complexities, right? You have recently instrumented sensors, and sensors are spitting data through the MQTT protocol, but maybe your PLCs were programmed and they are spitting data. Something else kind of brought together at an MQTT broker or whatnot. It's very important for the gateway, the IoT gateway, to not create a huge services exercise at the plant level to be able to pull data, understand the space of the individual data payload, and build that contextualization, the contextualization that leads to what we call as the unified namespace. That really across the plants or within the plants, across the lines, have that common technology you're on top of, right? The challenges are at the grassroots level. Everybody can say they can connect, but connecting that using this concept and layers of ontology, which we call as knowledge graph, that's where the value add comes in.
So I want to quickly show you what a orchestration pipeline or pipeline looks like. So, this that we have here, this shows you the different steps that you might be using. So actually, maybe I'll use a different example here. So, sample data pipeline, right? And of course, we have templates, different types of pipelines that we want to build. So the first, of course, is data retrieval. So when you go sort of deep into the data retrieval, let me show you one possible way of doing this. So a lot of our customers, they actually prefer that we don't install anything in their OT system. So their IT teams actually prefer pushing data to the platform because that's just the safer way. They are exporting data into an SFTP server. We are looking for changes in that SFTP server. We are gathering those files and set up by a user who is not necessarily a data scientist. This could be done, by someone who gets maybe a week of training. And all of these models that you're seeing, these have code. There's software underneath, but library that is already available. So if I just show you, this has a massive amount of different types of modules that are already available, and it's something very, very custom that you always write that code. Some programmer can write that code into your system, and then it becomes available for everyone. So here, you're getting the product from name from the SFTP path, or counting the files, then your system for it to the data pre-processing, the data processing, you're doing things, filtering files, you are removing empty rows, removing special characters. All of these are, important things that you have to clean, replace. So you see the amount of, different small little things that you have to do. And traditionally, all of this would have been written by a data engineer in some programming language. It's very hard to maintain because the person who has to maintain has to know the code. But here, it's the visuals, splitting the record and so on. So of course, you want to ingest the data as well. That's another piece of this. So now let
me jump in for just a second.
Yeah.
So keep in mind two value props in here, right? One is the data pipeline is showing there are a lot of I call them as the suspects that find at the plant level, at the operations level, a historian, OSI or other historian. Then you have the PLCs. You have and then you do FT, push it into as there are usual suspects, more or less, in the plant ecosystem. And there are a few that really connect to the enterprise. SAP is one example. The ERP data comes in. We have built in the library of pipelines that you can solve off. Instead of having somebody build it, figure things out, all you have to do is take this, customize it to a limit, configure depending on how it's set up, and you go in. For example, we have a SciPy connector that can pull the data up on the API-based logic on top to batch information or the performance of the assets across a certain set of batches or timelines and so on. So that's the value prop that comes in. And the second element, like he said, is this whole pipeline is connected back into the whole architecture. So if you already have a data lake, if you have your data sources, we are not expecting to duplicate all the data. What it really does is builds that layer of contextualization, keeping the data where it is. So you are not worried to say, oh my God, I'm duplicating the whole petabyte of data again to do this. No, we have the capability to really work off of the running data.
Yeah, and so now you've brought in the data, you've cleaned it out, you made sure that you trust that data, that it's reliable, that it's good, and now you're adding context. And so when you add context, you want that contextualized data to be accessible to the right people, and it has to have the right amount of context, and people should be able to add more context as well. So that flexibility is always required. So the main point of this is that because all of your data is in one place and is contextualized, the way that you access data to build a new solution, a new application, is the same across the entire organization. You're using the same interfaces to get that data. Earlier, what would have happened is, let's say there is a performance engineer who's trying to build some sort of performance forecasting solution, and then there's another engineer who's trying to build, let's say, a demand forecasting, and another engineer who's trying to build maintenance prediction algorithm or something like this. All of those people need data. And traditionally, all of them would have built separate pipelines for themselves. They would have, tapped into a historian and said, I only need this part of this data. I need to go to another data source and get maintenance information, but I only want this kind of maintenance information. So now you have all of these data pipelines that have been built from all of these different data sources, and it becomes a nightmare to actually maintain over time, which is why scaling is so difficult. But with a unified namespace where you have a single source of data and there's a single contextualization layer over it, everyone accesses it in the same way. And so that helps you scale and maintain in a very standard way across the organization. So what I want to show you next is how we add context and what kinds of context we might add. Okay, so back on this screen. So now I'm just going to go into this set and process definition tool here. And once it shows up, comes up here. Yeah, so here you see there's a large, long list of assets here. And these are essentially a software representation, a virtual representation of your physical system. And so let me go into one of these. This, I think, is a so if we go with it, what kind of information does it have? It has general information about what's its name, and model number, and so on. But then it also has all of the different types of sensors that you may have on that particular equipment. All of that, its unit, its interval, its lower control and upper control limit, all of that is captured. And then you also have some derived quantities. So derived quantities are mathematical expressions that you can create to create new features about that particular piece of equipment or that system with the knowledge of already, you already have knowledge of its physics and thermodynamics. So you can create features. So you can use a very simple expression language to build these derived channels. And then you definitely need to have mapping of tags. So the mapping of tags, let me just show you something here. This is a mapping of what the plant tag is from the historian or SCADA system. How does that link to the particular piece of equipment that you built? And now what you have is the data from a particular sensor that goes to the correct place. And because of this, now everyone can access that information through the virtual that you've created of this asset. Now this can be quite time consuming, right? There's thousands of tags, 10,000s of tags in a facility. So there's other tools that artificial intelligence has enabled, or other has enabled productivity. So one of them is the ability to use PNIDs and use the latest AI vision algorithms to actually read the PNID automatically. And in a minute it'll come up. But this algorithm now has basically identified all of the here on the left on this PNID. It has located where it is on that PNID. It has also figured out, like for example, click this, which is an expansion tank. It identified it as a storage asset. Also found that there are switches that are, because they're connected on the PNID. Of course, you have the ability to, this, of course, this somehow can read this. And once you list for the entire PNID, lists of PNIDs, then you just download that mapping, use the mapping to map it your virtual that we saw previous screen, and you have a accelerated way of getting where you have data in one place and contextualize. So this is one of the tools that AI is also to accelerate this. I have to speed it up. All right. So now I also talked about the knowledge graph. What is the knowledge graph? And so I think I have knowledge graph open here. So we'll go to that. Yeah. So this is a knowledge graph that was for a and there's a power plant. And what you see in all of these are different assets that they have, how they relate to one another, and also if you can search, let's say, for these, let's look at this B1 BFP, which is a feed pump. This information is coming from different data sources. There is a data source that has its time series. There's a data source that stores all this document. There's different types of documents. Some of it is stored on the store, there's another data store, other asset management. So all of it is sort of being brought into one place because you have a single access layer. And it's also able to find the similar assets that are exactly like its assets. And so you can build layers and layers based on your use. And if you go to any of these, this was the expected, you can see that you have all this information also available here. So click on this, all of its answer, there's some problem. Let's click on it and I have to data.
Dynamic layer, what is space, ontology, really you to create plant level or multi-plant level layer for drawing your knowledge together. So you saw Pratik presenting a co-pilot where the industrial co-pilot grounded, focused on getting your problem solved, not a generic co-pilot. It feeds off of that knowledge in the manufacturer's, on top of the manufacturer's knowledge graph. And then it feeds off of the generative AI capabilities of the LLM, as well as the predictive nature that we add to it. So together, this knowledge graph really becomes that single source of bringing the whole context together.
Yeah, and exactly what Srinivas was saying here. This knowledge graph here is the single access point for all of your predictive models as well as your generative AI models. And so the predictive models and the generative AI models, things like the industrial large language model, they're working in tandem. They're getting the data from a single place, and they're able to do different types of tasks. So the predictive models are really good at doing things like anomaly detection and regression and classification and so on. And the large language models are really good at helping you explore the data in a free-form way, being able to explain what's going on, being able to generate human-readable text and recommendations and insights, and also generate things like plans and things like that. And so it's a real combination of the domain knowledge that you have codified in your data contextualization layer, and also the knowledge graph. And you're now able to use AI in a way that you actually trust, and you're able to actually explain what's going on so that you can actually trust it. So the final thing that I want to talk about here is sort of go back to what Srinivas was saying. What we're building here is to enable a different persona in industry to use AI. And in order to be able to do that, there's multiple use cases here that all of you probably are very familiar with. But it's always a combination of pre-built solution applications that you can get from many different vendors. You can also start nowadays, you start using copilots with large language models to make that interface much more seamless, much more intuitive, or you should be able to build your own as well. And that's where a platform that that enables this is really critical.
So maybe call to action a little bit, just in case, right? I'll touch back to the comment that Pratik has made. I know you guys are staying a little longer than scheduled, so bear with us. There was a lot to show. We tried to short circuit it in the interest of time. But the point in here is, as you see it coming in the 3 sessions, one just concluded as a platform or what we call as the Iris Foundry. The whole idea is to really reduce the pain points of taking the data, picking the right context, right, and the information, and then bring it back to the end user in a highly disruptive manner, right? Using the copilots, the dashboards, responding to the copilots, and so on. So one better way to look at this is to really work hands-on with our technology, right? So if you have any use cases, if you want to really work with us, do a proof of concept, absolutely, we would like to, bear open that platform, work with you, and showcase the value of what it really takes to bring in a bunch of assets, look at their performance or a process, and try to look at how the optimization element of that process goes, and so on. So with that being said, the next 2 sessions will actually look at 2 things. One is 2 applications that we have that sit on top of this Iris Foundry and really enable the value. One is the predictive maintenance asset performance management solution. One is the connected worker, the mobile worker in the shop floor. So with that, we'll follow up with the next session.
Thank you very much for this deep dive, and without any doubt, there's much questions, much to talk about, and you could do this during the break. So we are going to break until 3:15. So 15:15 we start again.
You still remember me?
Yeah, hi, how are you?
We never met face to face, right?
Never did, yeah. Nice to see you.
Zeer goed, hè? Dankjewel. Dank u. Going to charges. Ja, zeker op tijd. Ja, zeer goed, hè, de presentatie. Wordt Copilot ook nog een keer...
Mr. Nishanta, excuse me, Nishanta Kumar. So welcome also. And,
thank you.
Okay, I'll give the stage to you, please.
Okay, go ahead, Sudeep.
Thank you. This is more in the asset actually enable. So I think from all the presentations today, this is probably pretty clear. Traditionally, if you're looking at what has happened, predictive AI, an asset. With generative and predictive AI, which is where we are here today, you can also get prescriptions and generate it. You can do what if questions. In the future, we expect a lot of the industry is going to actually be autonomous. So we are heading in that direction, and it knows about this curve. We've been doing pretty well if we are, somewhere in this preventive or predictive area, and of course this is absolutely required. But in the future, we're going to be able to do predictions and take actions well before failure begins. And that's predictive and generative AI are being used to today.
Provide the analysis informations. But the thing is, they were not able to drive the actionable insights of them. So they're down, right? And that and gathered all this data, process data, historical data, tapped into their vision, and tried an AI digital twin, which can go ahead and tell us what is going to happen in the future with a great confidence. And that is where they were able to go ahead and manage men, material, and logistics accordingly. And now their journey with us. Now we are empowering almost like in 9 plants in the US, right? So use case regarding glass industry that we are working on. So if industry that we had was something like the productivity, and when you talk about productivity part of it, and these guys were losing a lot of it, right? The reason is defects as maybe that looks very nice when you see it in a glass with which you drink water, but might not be very good when that particular glass is used in some kind of pharmaceutical. So that is where all these defects were one of the challenges for this. Probably another defect can be something like a platinum defect that they had when we tried bringing in. So one of the points that came out very clearly is to maintain a homogeneous temperature all across. But when we as the plant working at your end, and how do you manage this kind of temperatures at your we see a drift happening in the temperatures, right? So this is kind of a reactive action they were taking, and with this reactive actions they were working in the
Okay, thank you, Nishanta. Good afternoon, everyone. My name is Ben Engels, and my role within Nippon Gases is Reliability Manager, Europe. And so, first of all, maybe about the company. We are a supplier of industrial gases. We have a broad portfolio of different gases, industrial gases, for a lot of different applications. But I'm specifically responsible for the reliability programs of the bulk atmospheric gases installations. And this department, so the bulk atmospheric gases department, is operating large air separation units that split air into nitrogen, oxygen, and argon. So also in this case, those gases are not only production critical for the customer, but also can be safety critical. And that's also why our installations are running 24/7. And reliability is really key. So that means also over past years, even decades, we have implemented already a very comprehensive condition monitoring program. And I must say, up until now, vibration analysis, oil analysis is a very important layer of protection against unplanned stops. But we are also aware that those classic monitoring technologies are not covering every failure mode. And that's also why we decided to start our predictive maintenance program with the implementation of APM software. So not only as a company, we wanted to miss the train of Industry 4.0, but also we wanted to cover the failure modes that could not be covered by our current condition monitoring program. So up until now, we have started already more than 2 years ago. So we have already booked some successes with the implementation of APM 360. But we have selected now 2 interesting cases. So the first one is the affected asset here is a middle voltage big size motor, which is driving a critical air compressor. This motor is water air cooled. And of course, this motor is protected. So this motor will shut down on high stator winding temperatures. So the issue that we had here, due to a malfunctioning of a valve of the cooling water system, we had some air ingress into the cooling water system. And as you see on the picture, so this motor was one of the highest points in the installation. So the air was trapped on that highest point. So meaning the heat exchanger for the cooling of the motor. So with the APM software, we were able to detect already in an early phase that there was a problem with the cooling water system, and so with the cooling of the motor. So you see already some hiccups from the beginning. And finally, at August the 11th, the anomaly score tends to increase very much. So the anomaly score is in fact the output of the algorithm. So every value below 1 can be considered as normal. But you see at a certain moment, it raises up to 10. But at least it was before our DCS system detected effectively an alarm. So the operator at that time had still time to bleed the air out of the system. So by using the alerts or being alerted by the APM system, we were able still to react before we had effectively a shutdown of the motor. You see also below in the recommendations that were related to this alert, that also there were indications that there were problems with the cooling water system. This is the multi-channel view. So, of course, there is a correlation between, you see below, the motor air temperatures, and there is, of course, a correlation with the motor power. So the red graph. But you see at a certain moment, also in this phase, that this is not really correlated with the motor power anymore. So here we already detected some problems. And then finally, if the anomaly score was for a longer time above the 1, an alert was generated, but still giving enough time for the operator to react. Then we had the second interesting case. This brought us not really the big savings, but it's more a proof that the system is able to detect an anomaly long upfront. So this was also a critical air compressor in one of our air separation units. It is an integrally geared centrifugal compressor, and you see on the middle picture the inlet guide vanes, and those are used to control the flow of the power of the compressor. So by an actuator, we are able to control the angle of the inlet guide vanes. And at a certain moment, we see that those are not reacting properly anymore. So, and that's also explained in this graph. So you see the dates also. At a certain moment in January, there were already some hiccups where the anomaly score is above the 1, but not enough to detect already or to generate already an alert. But then you see, after some days, we are getting alerts regarding the inlet guide vane system. So we get also the recommendations on the right below. So check process parameters, inspect IGV functionality. So this proves that we were already able to detect this issue 1 month upfront. So, and that gave us opportunity to plan the necessary corrective actions. So to order spare parts, prepare the work, and so on. So, and this is also what we see in the parameter analysis of APM 360. So you see a good regulation from the beginning. Then at a certain moment, the inlet guide vanes are stuck. And we had to run the machine for a certain time, not under the ideal conditions. So, and that were the 2 cases I wanted to present.
All right, so we are back, or we were back, and we're back again. So very quickly, what Ben talked about, what Nishanta talked about before that, those use cases were asset performance management. And what I want to show here today is how we can actually get to that point in a very streamlined, no-code manner. And that is enabled because of the platform and how organized the data and the tooling is. So we're going to go into this MLOps studio here. I have it already open up here. This, maybe I'll zoom in a bit. So this is a no-code process. So I'm going to just use one hand here and go through building this model and deploying it. So we have something called AI projects. You can create new projects for each of your different use cases. So this is a ball mill, let's say, and I want to run anomaly detection on it, the similar use case to what Ben just showed us. And so let's create a new experiment. So we'll call that experiment a ball mill anomaly detection, and we'll select the problem type anomaly detection. We'll create a new project. over here, we can simply select your, if you have a training data set, you select that. You can select your testing data set as well, or your scoring data set. You can preview that data. So you can see it as actual numbers. You can see stats on that data. You can also, explore that data as different types of visualizations. Whether it's a line chart or you want to see the distributions or correlations between them. So this is just looking at your data and preparing it. And once you've done this, you can also select an FMEA rule set. This is a failure modes and effects analysis, more specific to the asset performance management use case. And we can actually create this project. And now you can create different runs to run your experiments. So one of the things you want to do with your data, of course, is to pre-process it. There's different options to pre-process. So let's just run some default pre-processing here. Of course, you can add different types of pre-processing that you need. So it pre-processes that data. It removes some data that is maybe not is faulty in some way. You can see the distribution of all of your different censored trends over here. So once you're happy with this, we can move ahead. We can set up some training parameters for the particular algorithms that are running. We'll just use the defaults here. This is, again, pre-processing for the testing part of it or the scoring part of it. So we can skip this for now. It'll just use the same pre-processing as the testing and set up some more parameters for the testing. So now what it's going to do when I click this run button is that it's going to take that training data set. It's going to train on what behavior exists in that system. And then it's going to use the scoring data set, which is data from another period of time. And it's going to compare it against the behavior that it's learned in the training data set. And any deviation it finds in the testing data set, it actually flags as an anomaly. And then it can run machine reasoning systems to come up with the cause and recommendation. So the run has completed. So let's look at the results here. You see that this is the score. Ben was just talking about that. The anomaly score seems pretty high right from the beginning. So let's take a look at that. And just give me a second here. Yeah. So now when we're looking at the alert, there's an alert right up front with the cause recommendation and ability to actually look at exactly what is causing that particular issue. And if you're happy with this experiment, you can simply click one button and use it in a deployment. You can replace an existing deployment, or you can create a new, completely new algorithm or use case and deploy it. And this is how easy we can actually make it once you have the foundational building blocks that we talked about on the platform. So I will hand it over to Nishanta to show you what more we can do with after deploying these types of models.
So with this, let me take you to a predictive portal or a unified portal platform. So generally what you see here towards your left is the digital representation of your physical system here, right? So if you look at, there is an enterprise, there can be multiple different segments or sections to your business. And then under that, there can be multiple different plants that can have multiple units and can have multiple assets, right? So that is completely replicable here. And when you get into a particular business or an enterprise, so what you generally see is when we talk about APM, it's about performance and health monitoring, right? So you just come in the morning, take a look, okay, my health is 91%, which means things are all running good, right? And then you have a trend towards your right. And what you see here is there are period of instances where, I mean, your asset was not running, which says not operational. And then there are periods where health score, it shows the trend of health score, say 88%, 87%. And now when you get into this, right, now as an enterprise, so currently, I mean, you don't see any health scores here. And yeah, it's coming up. So what you see generally inside the historical health score trend are the impact factors. Right now, as a CEO or top of your organization, all you need to know is which are the plans that are working or what is the overall health of my enterprise. So if it is 91%, then where am I losing that 9%? Right? So which are the plans where I'm having that trouble coming from? Now, those are the impact factors can be easily specified. Like if you look at this particular plants here, probably that is where we are losing our health, right? And even you can go one level down and you can see what are the particular plants this impact is coming from. And if in that particular plant, which particular unit it is coming from, right? If in particular unit, which asset it is coming from. You can drill down to that level, right? Right from the top floor to the shop floor, as we say. And then all you can see here is now, as I go to the enterprise level, the health, the overall, and the alert summary, right, for the day. And one of the things is critical alerts. So which of the alerts or which of the assets that you have here are not doing well and probably needs your supervision or something, right? And few of the KPIs that you would like to see, right? But let me just take you to one level up here, right? So you can definitely do it as a plant engineer. Yes, it is okay. You can go ahead, look at one of the assets. You can identify and analyze the faults, right? But as we go up and rise up this hierarchy level, right, when you have multiple of assets, you have multiple of plants, right, where we are kind of doing an enterprise deal. It's not possible for one guy to look at, say, all the assets in a particular unit right now, right? So that is where this APM Copilot comes in, which adds in a lot of efficiency, a lot of effectiveness to the user who is using this. So probably let me show you an example with this. So this logo that you see here is the APM Copilot, right? And what you can do is, as a simple user, you can talk to it, send some prompts, something like, what are the list of alerts for Feb 2023? Can be something as easy as this, and this can dig deeper, right? So as it is generating this response, let me tell you what's happening here is it is going into taking your prompt, trying to understand this, getting into the multiple databases that we have, and trying to fetch all those information, right? And converting it in a way that you can understand and probably getting or publishing the result. But for, and that's the reason why it takes some time as it's taking. So what I've done here is I have gone ahead and pre-populated some of the question and answers here. So which assets, now if you look at the questions that have been generally asked in the morning by one of the plant engineers, is like, which assets have 80 alerts from Feb 2023 and how many alerts for each asset? Right? So it is providing asset name and the number of alerts that is provided. Now this guy gets curious about this BFP pump and asks, list the 80 alerts for A2 BFP pump in the Feb 2023 region in a table. And that is where it is providing all the alert IDs, when it was started, when the alert ended, and the description and the recommendations to it, right? And then finally, say you are interested and you want to dig a little deeper into one of the particular alerts, say the last alert here, alert 15894. So I go ahead and ask, what are the contributing factors to it? Why is it occurring, right? So what it does is, it gives me the top 5 contributing factors, right? And the top one that you see here is kind of an inboard journal peering, which is creating a trouble. And then I go ahead and try to dig a little more deeper and try to analyze it. Right? I ask it to go ahead and plot this particular parameter from 2 different time frames. One is February 1st to 15th 2023 and compare with the data that we have for June 1st to 15th, 2022. And that is where you can see a complete difference in the region in the June. I mean, it was higher, and if you look at the parameter in Feb, so it is already, so these are the reasons, right? It is completely pulling out the reasons why things are different in both these regions. And then there can be one of the things, right? I mean, as you are getting more and more alerts from this section coming from, you can be curious, okay, I want to understand how the things are going to be in the next 2 to 3 days, right? So this is where you see as part of a forecast, right? So February, say 22nd, 24, 26, 28, it was something in a rising trend. And if you look at a forecast for the next 3 days or a couple of days, so still it is going to be rising. So you get to know what's the scenario is going to be for the next few days, right? So this can go long and long. You can keep asking it questions and it will keep answering you and take you to a lot more analysis. But the key takeaway that I want to pass on here is you have data that can be converted to actionable insights. And these actionable insights, right? So when you have a great and when you are converting this into at an enterprise level, you need effectiveness. And that is where the Copilot comes in and powers in with a lot of this technical effectiveness. Thank you.
Yeah.
Yes. Yeah. Put this down. And the mic.
Okay. Showing as small as possible and continue to share some insights with the young Afrisa and stay aware of the AI. So please, the stage is all yours.
Een bijzonder goede middag allemaal. Mijn naam is Jan. Ik ben verantwoordelijk voor de Europese markt. En ik ben heel blij om hier zoveel gezichten te zien. Een aantal Franstaligen met mij. Donc, zeker, vous êtes venus. What we've seen today, we've seen the data platform. We've seen the applications. But we still need to close the loop. Closing the loop, that means that frontline worker. So what we'll be doing today, by Stijn de Ketelare, but I first will give an introduction to what is a connected frontline worker solution and how to mitigate for a few challenges on the shop floor. So bear with me, I'm going to show you a few slides. These, I think you know them all. Outdated paper, standard operating, complicated instructions, and at the end, for some help. This is the reality at the. Now, if we dive a little bit deeper into those challenges in the workspace, we see that documents finally getting, but certainly up to date. Traceability and compliance, we know it all. We all hate it all. No management, let alone that data connectivity, operating procedures. Maybe the most important one is our aging population. Aging population, we have difficulties with the knowledge management, missing domain expertise, manage the skill level on the shop floor. So I think it's a good overview of the challenges we have in a modern workspace. So now what we're going to do, what is the solution? Well, we have the solution at hand. We are connecting the dots, connecting the data and the application. Force. we're going to do frontline solutions. We call it prosthetics. Application in a clear language with dynamic. I mean, you have a maintenance engineer doing some is not aligned with the workflow and make sure we have a more change. Have what context a level of maintenance on that. So have the language we have here today, French. He can ask a question, any language, in a natural language, and have the domain level expertise just outputted by the Copilot. For example, reading a 500 answer from you. So this is what is a connected frontline worker. I'm not going to elaborate on that. In general, it's action, it's instruction. We're having inbound quality control, walking the floor, line changeovers. I don't elaborate too much on that. The best thing we can do is show a real life example of what this would look like. So if okay for you, Stan, thank you very much.
Good, thank you, Jan. So, yeah, because over there, and we discussed an idea. And Peter envisioned the idea of having a chatbot that could use data that was gathered and could help the operator on the floor. Because what we saw at Proceedings, we could describe the processes as much as possible and as good as possible, but yeah, we don't know exactly what the questions are from the operator on the floor. We can't cover everything. And then, with Peter mentioning the chatbot, I think everything fell into place. All the dots connected, because with the chatbot, with all that data underneath, the operator himself can ask the question and we can solve the problem at hand. So that's my trip to down memory lane. But okay, let's dive into the fun part. You saw Nishanta talking about the Irish Copilot. I don't know if I can go back, but I'll just tell you. You have to take my word. So the Copilot itself, you can ask questions and you can get answers. But it's not only generating data or generating answers, you can also initiate something. And Proceedings is seen as I call it a box of, it's a Lego brick, and a Lego brick has connectors on the top, at the bottom, and you can connect everything on it. So we can also connect to a Copilot. If you say, okay, I want to start an inspection, because the analysis was done via the Copilot and we saw that something was wrong. Now we can start an inspection directly from the Copilot and bring it to the worker on the floor. So a direct connection to the worker, and the worker can execute everything and then can give feedback. He even can say if it was good or not, and we can even use that data to process. But enough talk. Let's show you something. And yeah, just not take my cell phone. Just a second. Maybe Jan can tell something. Joke maybe.
Well, I'm afraid I'm out of jokes, but we're going to prepare the demonstration now. So Stan is going to couple his cell phone to the screen. You just for your please use it on computers, on cell phones, even on glasses. The demo will be given today on a cell phone. If look, and there it is.
Okay.
My pleasure.
Next time the joke.
Next time the joke.
Okay, so as Jan mentioned, device agnostic. I'm using an iPhone. You can do it on an Android, on Windows, as Jan also mentioned, but also tablet and phone. And also smart glasses. We forget sometimes, but that's possible. And you can switch from one device to another. It's important. So basically, just to show you, when we start something from another system, it comes into the to-do list of the operator. So we bring it directly in this list of actions that you can do. And here, for instance, I have the bearing inspections that were scheduled for me, some conformity reports. But just for the sake of the demo, I'll use one in my template list, so I can also start from scratch. And I have here the bearing inspection for the connected worker. First thing that I can do is give it some sort of first database. We call it the case code. I think I have something here. Yeah, let's try it. So what I've did, we often see that a work order is used, so you see it at the top. And then we bring the data to the customer, or not the customer, to the user. And the first thing we see is a picture. And what
does the operator needs to know. And yeah, I think this is pretty clear. But yeah, he can also zoom into it and do a lot of stuff. But when he saw this information, he can confirm that he has seen it, so he can go further. And yeah, we can scan the asset code. So we saw the assets mentioned before. So to confirm it, we can go the same way and scan QR code. I think it's my shadow. It's messing up. Okay. So this is the A2BFP. That might sound familiar for some people. And we can go further. We can give more information. For instance, here we've got the GOG, and we can go to the next card. So that first one was informational, and the second one, we want to know the value that is indicated on the display. So let's say this should be something in the range of 5 to 10. So let's take 6. Apparently, I switched it. Okay, but let's move on. In the sample, we also have the temperature, and you have the temperature gun that you can use. So you bring the information to the operator again, how you can use the temperature gun, and then let's say the value is 100 degrees. Good, but now what you've all been waiting for. The question, do you hear any abnormal noises from the asset? Question is, what is an abnormal noise? What is it here? I don't know. So maybe I should ask the Copilot. So we have integrated the Copilot in the overview. Copilot help. You see the same interface as you saw before. And query here. And now I'll show you a little trick that I learned from my two daughters. They never type something. So let's see. What are some abnormal bearing sounds? Yeah, it's registered also my previous screen, so blame my daughters. So, but it gave me an overview of the possible bearing sounds that are abnormal, so we can take a look. Okay, so let's say based on this that I have an idea what I need to say. The bearing is continuously howling at high speeds. What could be the cause, and what should I do about it? Okay, so we get an immediate answer, and it says, I can read, but it also says that I think it mentions that I should stop normally.
He understand cost instead of cause.
Sorry. I'll give it a second try. The bearing is continuously howling at high speeds. What could be the cause, and what should I do about it? Yeah, that's good. Yeah, now I get a good answer. What I expect. And basically, it says that it can be poor installation, and it also says that I should stop the inspection and should escalate it. So based on that, I'm good employee. So I'll request an action and I'll escalate this to my supervisor. I'll say it's a maintenance issue and I'll send it to the operator. So basically what I've done, and we've initiated an inspection, we executed it, we used some of the standard procedure, then we used the Copilot, we got a response saying, okay, this is not good, we should stop it, we should escalate it, and that we did, and we brought it back. And all that data is registered in our system, it can be reused, it can be even reused by the AI model to improve and to learn. So I think that's it, and if there are questions afterwards, we can have a talk.
Yes, okay, thank you very much. So, looking at the timing.
So looking at the timing, it's time to, now we have some more time for Q&A. So what I would like to do is maybe invite everyone that has been presenting today to join me here at the stage. So please, because I'm not going to answer the questions here. Thank you for the applause. Yes. Please join us. So also the technical guy, thank you very much to stay with us here. So maybe because there might be some questions that maybe need a screenshot or something like that. Okay, so let's kick off maybe for the first question. I know it's always difficult to break the ice. So my first question is regarding the co-pilots. These co-pilots are trained and are using information also. So can you elaborate a little bit where this information is coming from? So is this co-pilot pre-trained by SymphonyAI already? Or is it also taking up information from manuals, etc.? So can you elaborate a little bit on that? Where is this knowledge coming from?
Yeah, so that's a great question, by the way. So I'm going to explain to you how our Copilot is better off at giving you more focused, precise feedback, right? There are a couple of different ways we have trained our Copilot. Just so you know, we have 40 years of background helping customers doing the condition-based monitoring and the predictive maintenance on a lot of rotary assets. And roughly, we look at roughly 40% of the plans, having 40% of their assets working off of the maintenance, the reliability aspect of it. We have done those maintenance. So that information on the asset behavior, the vibration data, as well as the work orders on the maintenance side, that's what we have based off of. So roughly speaking, I think we do a slide there, 1.2 billion parameters of information working off the 40 years of maintenance records that we have looked at is what the size of the data we have used to train the model. So now it's all data that we have taken in from our work experience with our customers on their assets, but completely anonymized. So there's nothing proprietary, nothing specific about the customer or their process or their assets that's being trained in. What it generally learns is what is the asset, what class of the asset it is, what kind of failures that it can potentially have based on the conditions, not just the operating conditions in theory, but also the actual conditions on the physical side of it, and then what kind of work orders and maintenance has been done in the history based on that. It starts giving the insightful feedback. So that's one source of the data that comes right off of the LLM when we come to helping our manufacturers. The second source of the data is the knowledge graph itself. So that's all is based on your specific information that's coming in from your data sources, your assets, your processes, real time. And that's where the knowledge graph is going to add in as a second layer of functionality. The third one that the Copilot takes off is the predictive side of it, right? As you all know, the generative AI Copilots are all about drawing insights, communicating in the natural language. But the predictive aspect of it, the whole predictive AI models, it has to really augment with the tools like the classification engines or the the regression engines and so on. So we use the third layer to really apply the same data, feed it to the predictive models that Sudeep showed, draw the predictive insights, and bring it back to the end user through the Copilot. So these are the three key areas.
Yeah, okay. And maybe a little bit, elaborating a little bit, so think about your questions. Elaborating a little bit more on, okay, we have seen a demo on how to ingress or take in a PID graph, but does that also work with written manuals? So we have kind of equipment and you have a technical manual, big document. So how is that knowledge also ingested into the system, and how does that work?
Yeah, so the large language models have a couple of different ways they capture the data, draw the insights, and render it to the end user. One of the sources of data could be full text, content that is sitting in your PDF documents, other data sets that are sitting there. What we do is we index the data and be able to pull in the right contextual paragraph or the line of the data and be able to bring it to the end user during the activity. For example, right, like you said, more often than not, the standard operating procedures and other things have a 500-page document, a PDF document sitting in some corner. The operator who's walking in sees a situation on the shop floor, is not able to immediately decide on what actions they have to take to mitigate the problem that they see. Now, they're running off of the workflow you saw in the connected worker, but then there's an underlying standard operating procedure that's tied to it, and that has one line item that describes how to take the mitigative steps. We will be able to pull off, based on the context, that particular snippet of information and then give it to the end user, right? So
yeah, okay, and then the final difficult question, maybe, I don't know, but how does the system relate information in manuals to this this graph, or to this the right pump? So because in a documentation they're talking about a pump or the pump, but how does the system know there's this pump in this installation in that plant? How does that work?
Yeah, so you can visualize this a little bit, right? We try to touch on some areas that certainly bring the answer to that. The knowledge graph, think of this as layers of graphs that are sitting in, right? The contextualization happens at multiple levels. For example, when you're bringing your asset, the tag information, there's a level of contextualization we do. Then you bring in your PID diagram, or some of the mechanism that really shows how your process flow is happening, how your assets are in the line, and so on. That again comes in and creates an asset structure and another layer of contextualization. So as we start drawing the layers of contextualization at the core level, the ISA 95 asset structure, then we bring in the process flow, then we bring in the documentation information. In parallel, we bring the work order information. Think of these as layers. So the layers of contextualization starts coming together. So if, for example, you're walking up to an asset, you're determining an anomaly, you need to take a mitigating action. The graph is able to figure out what asset it is based on the PID information that you've plugged in. Of course, you can use more sophisticated ways of, scanning the tag on the asset or whatever. But once you determine what the asset it is, it knows through the layers of contextualization that, okay, this is the asset class it belongs to. These are the channels of information we're getting from the sensor. These are the previous work orders that are being implemented. These are the standard operating procedures on these assets. This is the asset, this is the downstream asset. Right now, these two work orders are being implemented on this asset. So now if you have to really bring in downtime, your work order has to be reprocessed to a different asset line or so on. So these layers of information is brought into this knowledge graph together. And by the way, the beauty of it is, like I said in the presentation, it doesn't have to be that we have to pull data from all the sources and bring it into our system. The metadata, as we call it, or the contextualization is where we sit in, but we can keep the data where it is. Maybe in your CMMS system, it may be in your asset system, or it could be wherever it belongs. But that layer of contextualization brings in that value to the end user. Right? The last part of it is, right, why would some people care about the work orders? Some people care about the asset upkeep. Some people care about getting their throughput from that asset so that they can get the product out into the market. There's not one person that wants everything. So that's where the user-based activity comes in. For a reliability engineer who's walking around responsible for the upkeep of the asset, we know what his role-based context is. For a production manager who's trying to keep his schedule going, will give him the information based on his role and his context. Long answer, but I just wanted to make sure that the platform enables you to do this within a plan, across plans, connecting these dots so that, and do so in a more configurable way than to just make it a science exercise of trying to connect things one time, and when you want to replicate it, it becomes difficult.
Okay, so anyone has a question ready? Yes, there are some questions here. Can I start with you? You're close by.
Thank you very much. So, kind of difficult question, sorry for this. So, when it comes to investing in such technology, users actually have in mind what it can save for them, and the ROI question comes. So, they know how much you will invest, but they have no clue what you will save. So, how do you actually overcome this objection with customers or users?
So, objections from the customers on the ROI?
On the return of investment of such technology.
So how do we convince the customers that there is an ROI from what they're doing already? So that's a great question. Quite honestly, I would like to hear from you, maybe not in this setting, but in a follow-up setting on how do you see the ROI, from a technology like this. But I'll give you some examples. I'll pass it on. A lot of the times, you think it's easy, of course, you've been living through this. A technician doesn't know what the mitigation plan is. He has to follow it. He takes a checklist, checks off on things, but he cannot say on his own, can he recommission the asset which has gone through the maintenance? And he has to follow a certain protocol for recommissioning the asset back into the status on. And more often than not, this procedure is not properly set up. They don't know what the aspects of check marks they have to do to take care of this. In a situation like this, having the solution at hand rather than him calling somebody else, figuring these things out, that's one area that creates a high element of productivity. The second part of it is, I have spoken to enough plant managers where their job is, they call it shift exchange, or as they come in, they do their shift analysis, how are my resources doing, how are I delivering on my work orders, how are my assets performing, what is the capacity level. Then they start doing this planning for the next shift. More often than not, they're working off of the data that is stale or doesn't have it ready for them to make some key decisions. So a technology like this really enables them to be working off of more digital communication methods to bring in more productivity. So those are some of the examples I can think of. Certainly, as many customers I've spoken to, the ROI is surely there. And maybe I should ask you to throw some light in it.
Yeah, what we did to build a business case, for example, as I explained, we have already a condition monitoring program in place, so a lot of unplanned failures were mitigated by the existing condition monitoring program, but then we did also an analysis of our unplanned downtime events, which were not covered by those classical condition monitoring technologies. And that's the way we assumed then that we could cover this by API software, and that's the way how we built our business case.
Mm-hmm. So Ben, maybe you can elaborate a little bit on how much improvement did you get about this unplanned downtime?
Yeah, for the moment we are still in the implementation phase. I think for the moment we don't have the figures really to give an answer for our complete installed base in Europe. So at this moment we are in the half of the implementation phase.
Yeah. Okay. So that's for next presentation then. Yeah. Okay. Good. There are questions here also. Yeah.
So one other thing is we talked about the asset performance management, but once you add the co-pilot on top, the ROI then takes the whole next level, because now you can do even what if analysis, right? And scenario planning, what could happen if this and this conditions persist, or this and this XY happens. And that what if analysis is the whole next level.
Ik denk dat wij wat vroeger zitten op timing.
Ik heb het dan al laten weten, dus ik ben aan het praten. Of zijn er bijna?
Nee, kom gewoon af onder de vragen op zijn huis op.
And that's where you don't need to go and ask 100 different people that have information. Go find and pull all that information based on your knowledge graph, based on your information in the plant, based on the future. You can even go into the details and say, hey, how is the industry doing it? What's the industry standard for this? How am I performing with respect to the others out there in the industry? Because the LLM is trained on the market data as well, right? So tell me a little bit more. What is the steps which are bottleneck in my case? How do I improve on that? What is the efficiency of my work, right?
Ja. Nee, gewoon like vanmiddag. Vanavond zouden ze minder.
Thanks for the presentations. One thing I really like is also so I really like the knowledge graph. I'm also very in favor of that. The main thing that we see issues with is the maintainability of such thing. Building up something like connecting all the dots, connecting them is already a big task for a large company. Let alone keeping it up to date and keeping it alive. Because all the information, pulls it in, pulls it out, those kind of things, you really should be careful about that.
Excellent question.
So I think the question, as I get it, it's great to build a knowledge graph like this and work off of it, but how do you keep it, how do we have it keep going, upkeep of that knowledge graph, keep it current, keep it going? And there's a lot of resources that you have to allocate to keep that up and running. I think it is part of an ROI question as well, but that's where the platform like the Iris Foundry that we brought in came up, right? That came out of all these exercises and experiences with the customer. We pull the data together, contextualize it, annotate it, give the asset structure view of it based on the asset class. We define the failure modes, and the customer is liking it, but then applying the same across the same set of assets of the same class is becoming slightly difficult. So at that point in time where we started these pipelines together to say, once you have right down to the ML ops model, to the data transformation lines, the idea is to really do that. That is, once you have the pipeline set up, once we have the unified namespace definition being brought in, once you have connected to your data sources, the system is smart enough to be able to pull the data together based on the configurations you set up and tries to keep the knowledge graph up and current. So, I mean, like I keep saying, if you really want to define us, there's one end of the extreme where somebody's doing it as a services effort, in which case, obviously, there's a lot of effort that need to continue to happen on a regular basis. There's another extreme where maybe there are technologies that are hard to bring into the ecosystem and come in and be able to show the value real quick. They may have all the bells and whistles, but they're really hard to adopt into your ecosystem. We place somewhere right in the middle. Having seen experiences like this, where the value needs to be brought in by having very configured, productized layers to it, we brought that into our platform.
I think I want to add one more thing. So what we couldn't show in the demo because of the constraint of the time is that you're not starting at the knowledge graph from the very beginning as a single node, right? That would be a daunting effort in terms of time to go build the knowledge graph. There is tools which allows you to start as Srinivas was saying, you do the PNID ingestion, it automatically creates that graph for you. So you're not going and creating it from scratch. But once it does that, the semantic relationships between the different nodes, and it could be the energy mass relationships, those get automatically created using AI as well. The relationships of what assets are surrounding it in proximity to this asset within the plant are also created automatically as well. Yes, you can go in and better define them, you can change them, update them, but they automatically keep on getting, using a deep learning algorithms, they keep on getting updated and added upon on there. In fact, when we started building the knowledge graph, we just recently added the API for you to go and update the nodes. We didn't even have that before because our anticipation over here is that the graph gets updated and built on its own and gets maintained on its own. It should not be the onus on the end user to go and update and build the graph. The whole ontology and the taxonomy over here behind drives the graph. And that now becomes a feed into the generative AI element in there.
Okay, two more questions. In the meanwhile, just about this maintenance of this data, another thing that can happen, of course, is that you get an alarm and an anomaly detection, but it can be caused also by a failing sensor, for instance. So how does the system differentiate between a failing sensor and an anomaly? And a second question then, of course, do you get an alarm if there is a sensor not working correctly?
Yeah, absolutely. I mean, this is one of the very interesting questions. So whenever there is an anomaly or any sensor getting bad, so we have sensor analytics running in the backend. And what happens is this gives you a clear indication stating that, yeah, this particular sensor has gone bad. And probably from there you have got a capability to go ahead and remove that particular sensor from the analytic and later get it back into the analytic when it is all right.
Okay. Thank you for the presentation, and it's a very nice system, but the experience that I think many people have with large language models is that if you ask the same question 2 times and it gives you 2 times a different answer. Have you got any experience with that? You have the same set of parameters or the same problems or things coming from your sensor, and it's giving you an advice that is 2 times very different. Is there any experience, and how do you deal with that?
Yeah, so we've done a lot of work, especially on that. Now, this is the same model which is being deployed across, let's say, thousands of plants, but at the same time, we're using this, what we call Generative and AI. It's being deployed by financial services across the world, retailers across the world as well. So we're definitely doing a lot to make sure there's a consistency in the response from the LLM, but at the same time, what's also very important for our users is that the response coming in from the LLM in the Copilot, which is a front-end UI, is not only consistent, but it also is a valid and a right response, right? How do you validate that if the Copilot is telling you something, it is the correct, and how do you believe in that, hey, it's the correct response? What if it's giving you a response to some other asset, when you're asking for asset ABC and giving you something else, right? So what we've done is we've added something called a truthness factor concept. So when we go in and you ask the question, let's keep it very simple, you ask the question to Copilot, it will show you the actual steps it took, and you can actually expand on that. It will tell you the actual steps it took to go in and find that answer, and how did it calculate and find that answer, and what were those steps. And you can go and expand on each of the steps, just right on top of the answer itself. It's kind of like a clickable view. You can go and expand on that, and you can see all those steps. You can keep going deeper and deeper into each step that the Copilot took to get you that answer, and that will tell you exactly how that answer was derived. And that's the same phenomenon that we're using to make sure that the next time you're asking the same question is consistent with the response as well.
Go ahead.
Thank you for the presentation. I have a question. You spoke a lot about big companies, but what about SMEs? Should they also implement AI for their asset management? Is this worthwhile, and what's the return on investment for these companies?
So, if I can repeat the question, you're saying, is the AI models that we are building, are they available worldwide? Is that what the question is?
Also small and medium-sized companies, yes.
Yes. So let me start by saying this way. So first of all, the LLM that we launched in partnership with Microsoft is publicly available with public APIs. So you can go over there, you can sign up over there, create an account, and you can start using it. Very similar to like ChatGPT, right? So we kept it very simple login process as well as the sign-up process. So there's no complications there. Especially keeping those SMBs and partners in mind, where we want to remove the barrier to entry altogether. So even a students can go in and sign up and start building prototypes and projects on that. That's where we want the LLM, the industrial LLM, to get used. But that's just one part of the equation. The second part is what we're also doing is for the SMBs and even for the partners which are smaller in size, we're making our Iris Foundry available as a demo environment. So you could actually sign up for the Iris Foundry demo. You can have your own demo instance, which will have the containers as well as the image specifically set up for you. You can totally customize it. You can upload your own sample data, and you can start playing with it. That is going to be available, I think, in the next 14 days or so is the timeline that we have internally. That should be available. You can sign up for that online and should be start playing with that. So definitely from whether it's an SMB, a partner, or a small company, we're trying to keep it very simple and keep that mindset very clear.
Okay. Any further questions? One here first.
Thank you for the presentation. Very nice system, by the way. You showed something about anomalies. For me, anomaly is there or is not. It's 0 or 1. Of course, you have false positives and false negatives. And do you keep statistics about these false positives and false negatives yourselves and give you true value to, let's say, a customer who's interested in this, in purchasing this system? Because that's very important. Because if I annoy my coworkers with false negatives or false positives, and well, false negatives are very dangerous, but they will not trust the system anymore. So how is that done? Do you give a clear view on this?
I'll say something and I'll let you add, right? So we don't just do the anomalies as a true or false, but we also do the further analysis on classification. If it is in fact determined to be a failure to classify it, try to apply the library of FMEA to say, based on this classification, is it severe, is it mitigatable, or is it just maintainable? And then apply the FMEA based on the asset, its performance, and the next level of detail, outside of just raising the anomaly. Now, your question is about anomaly cannot always be trusted. There could be false positives and false negatives. Yes, we keep the historical information on that. Sometimes what we call as human in the loop. That is, when the false anomalies happen, we get the human in the loop to validate it. And based on that information, there's a reinforced training that happens back into the AI model to say, okay, this time around I learned that I made a mistake, and then I'm going to use that as a way to, reconfigure my hyperparameters and be a model that's more fitting to the situation. So that's where the MLOps pipeline comes in, where it's not one model you build in, you deploy it, but as information comes in, as the false anomalies come in, we capture them, human in the loop gives the feedback. Sometimes the data patterns change within 3 months or so from what it has been trained on. So you have to retrain the model, and it happens through the ops pipeline. So these activities really enable us to continuously look at reducing the false positives and false negatives. So we have R-square and other capabilities that we regularly review to make sure that the model is neither highly overfitting, nor is it too vague to be providing too many false positives and negatives. So we have that built in.
Sure. So as you said, anomalies are something like 0 or 1. So I try to go far away from that kind of a scenario. So the idea is it's not always 0 or 1. Sometimes it happens that an anomaly is building up, right? So probably it might happen that you don't believe in the beginning that something is going to, maybe the second success story that Ben shared, right? I think it started almost like a month back. There were kind of alerts, but when they went ahead and looked at it, it was like okay for them, things were running good, but slowly when things went bad and it started building, right? I mean, they then went ahead and believed, yes, the alerts were right? Yeah, definitely. I mean, this is something on your first question. Second question, we do have false positives, those are sure, but initially when we start, right, the number is higher, but we, as we go ahead with the retraining, as Srinivas talked about the retraining of the models, and now where you can go ahead and give your feedback to the models that, okay, this particular alert or this particular event is kind of a false positive, you go ahead and tell the system that go ahead for a retraining, it goes ahead, automatically retrains and redeploys, right? But this reduces over a period of 2 to 3 months of initial deployment, right? And the number that we reach is about true positives of almost around 80% of the time. Maybe, Ben, if you want to add your experience as a...
Yes, I would say our models are trained with 1 year of historical data of normal process behavior. And the data is clean before the models are trained. But we see also not all operational situations, normal conditions are covered in 1 year of data. So we see when we start the implementation at the beginning, quite some false positives, but that's also good because for me it's also an indication that the system is working. If we don't have any alerts, then we were suspicious. So, but we see just a matter of analyzing every false positive, and also when it's really a false positive, to reiterate the model with the data of this during this false positive. And we see after a close follow-up of 1 or 2 months, that the amount of false positive is significantly decreased.
Okay, final question. Oh, yeah.
See, the Iris Foundry is one platform which allows you the capability to train as many times the model as you want, and apply versioning on that. And not only are you getting a UI-based tool to go in and sample the data, create the new model version, deploy it into production, but we couldn't show that today. You also can go in and use the Python notebooks, go and write that, and then deploy it through the Python notebook as well, right? So we have the full capability as part of the Foundry to not only just use the vision tool, but also deploy your notebooks directly as well. And then once you're deploying it, it maintains the versioning. You can deploy it for a certain set of data, the new stream of data. So you can set it all up accordingly and keep going from there on. And that's one of the biggest, I would say, differentiators for the Foundry compared to the other models out there, where you are limited. Every time you want to deploy a new model, you want to involve the company back in. There's a whole process around it. Over here, you go in, create a new model, start a new job, as Sunil showed you, and then just keep going as new data comes up or as new false positive comes up. Go back and retrain and deploy it, and within a few minutes, your new model is deployed, so that false positive is never again triggered.
You asked a very good question. False positives, you can never escape false positives. So change management has to be in place. And when you are rolling out a system, the education, the expectation management, the proper change management journey is essential. And that's what Ben also talked about. I mean, people organize, they drove a very strong structure, change management across his plans, and if that was not in place, people initially would have talked about the possible, but there was a journey, there was a tempering of the.
Okay, the final question.
I have maybe a more philosophical question. If you're a big company, you are developing such a system, and the more you are developing it, the better it becomes, right? So you add more data, you give feedback, but probably as a company, you're not sharing that. You keep that for yourself. And then there was a question on that SME, how do we prevent, or how do we make sure that these SMEs would also be able to jump on that development, because you don't have that much of data? How do you deal with that?
I think we answered that. The LLM that we introduced to the market is trained on 1.2 billion tokens, right? And that is based on the data that we collected but anonymized. So it's a level shared starting field. But then again, the systems that you're putting that LLM along with the graph that gets produced is going to be on the real data. It's going to be on the real-time data. And that means that the more complicated system you're going to put it on, the more amount of data that system is put on, along with the LLM, along with the other knowledge sets that you're providing it, the system will be able to perform accordingly, right? I don't think there's any way out of that today. But that's definitely, if you're using the LLM as it is, and without even connecting it to a live system, by the way, you can use LLM without connecting it as it is, as an independent LLM itself. You can ask the questions, give it the raw, I would say, data in the question form itself, and still be able to reply. That is another starting point, right? Which could be used. But then again, as you connect to live data, as you connect to real-time systems, that's when both upstream and downstream systems, that's where the real value starts to change.
Okay.
See, ROI can be measured multiple different ways, right? If you're thinking about the cost of the product for an SMB to use, I think Pratik answered that. It's not that costly that an SMB should not be looking at this as something that large enterprises should only use. That's number one. Number two, when it comes to the data, you're a smaller company. This kind of a technology is affordable. So one question is answered. But now you're thinking, I don't have those many assets. I mean, I don't have those many clients. I don't have that much sensor data. That's okay. Sensor data alone is not really filling the knowledge graph. There are so many events, alarms happening, coming in from the work order creation, work order execution, asset being brought down by a human element. This data itself is highly valuable for you to draw the knowledge and be able to leverage the value of the AI as well. Now, I mean, at the end of the day, you have to evaluate where the value comes in, but what I don't want you to walk away thinking is, if only I had 1,500 assets throwing gigabytes of data every hour, then only I can use the system. Not exactly. So that's where the knowledge graph element, quite honestly, sensor data is one aspect.
I think the truth is also very simple. Even if an assembly, if any system, any breakage makes your production, stops your production, and you're losing days of production, or you're not able to deliver value to your customer, the ROI is there. Right? If you had an APM system working that would have prevented an unplanned, unseen outage, your ROI is done. You just have to prevent one incident in a year, and it's a critical equipment in your system. Maybe just one compressor for your entire factory, but if the compressor stops without you knowing, it stops your production. So that's not a good thing to have. But if you have a system in place that can actually help you prevent it, the ROI is, it's done. Just one incident is good enough. We have seen situations where one alert, we have just raised one alert for the entire plant, and that has helped them in stopping, avoiding potential production loss for 3 to 4 days. And that's for a very large plant that could be millions of dollars of production every day. So one incident is big enough.
Okay, thank you, thank you. So following up on this philosophical question, I have maybe one final visionary question. So Koen of PwC, of course, PwC is also an expert in looking into how AI is developing. So I'll wrap him up a little bit, what you have learned and what we have seen today. How do you see things evolve in the coming months, weeks, year?
Now, months, yeah. Today it was in the thread and the echo that students and school teachers were already using AI. And I always say if it's in the newspaper, it's too late. So I think with the things that I saw, the AI, the machine learning, deep learning, and the Gen AI, it's all add-ons on the digital solutions that I showed. So I think in the coming years, AI will really take over a lot of the functions and work processes in the industry. But I see that my colleague from innovation, Peter, is here, so I think we can have a little discussion to do a new survey in a couple of years to see how the digital trends are and the implementations level are at the industry.
Okay, thank you very much. By that, I only have one more task to do, and that's asking you an applause to thank all our speakers. It's not all. I have also a nice little present for everyone here. And it's not, it's Belgian chocolates, so for the people coming from abroad, that's also important. But it's not just chocolates like this, the chocolates of Nauhaus. And I think there's someone from Nauhaus here. Are there? Already gone? No? Oh, that's a pity that didn't see, but they are a member of BEMAS, they were here. But so that's important for us also to support our members. So thank you very much. And the final words for you, please.
So I just want to say one thing. You asked great questions, we gave responses. Then there is always this, skepticism, concern. You have your own problem, challenges, and support. So one thing I want to challenge back is work with us. Like the Vic said, we have a lot of our products that are readily available for you to create your own demo environment. We're willing to work with you to build a POC or pilot or whatnot. We are willing to work with you, get it to the ground level, pull up our sleeves, and get some of your problems solved using our platform that can show the value. I think that's where a lot of the questions will hopefully be addressed. It's easy to answer the questions, but then we really bring the product in front.
Okay, thank you very much, everyone. Thank you also, Jan. And I would say the bar is open. There are also tapas, etc. So please enjoy and have a conversation with your peers here. Thank you very much. See you next time. Very well done. You're welcome. Here is also the Belgian chocolates for you, huh? And for you, of course. Yes, yeah. Thank you very much. Yes, thank you very much. Yeah, a little bit. Oh, it was very well.